factor models and dynamic fault trees using biographical reactive systems by P. Govind Raj and Subrat Kaur. So, if you please.
Hope I was audible before. So this is a joint work. I mean, this is a PhD work with Professor Subrat Kar. He's my supervisor, and this work is at the Indian Institute of Technology, Delhi. And what we are interested in is formal modeling for cognitive buildings. And what I'm going to present here is basically an extension of the work that I presented in the previous version of the Formal Methods Conference. So what I plan to do here is basically to give a high level introduction into the entire research and how we are placing the research. And the details are more into why we are doing this, and the paper has more details into how we are doing it. Okay. So, but I'll be happy to discuss the implementation aspects of it if anybody is interested. So we'll go with what the motivations are and what the backgrounds are. I'll give a brief of what Actors at BIM is all about. And I'll talk about specific extensions to the formal model that has been proposed in this part of the work, and then I'll conclude. So basically, a cognitive building is a paradigm shift from the static view of a building. Generally, as it's always considered as a container of human activities. But cognitive buildings are basically cyber-physical systems which are embedded with sensors, actuators, and computing elements. And it works by sensing, controlling, and actuating the built environment itself, right? So this could be smart offices or smart buildings, or a conference room which could change its shape with respect to the kind of exhibition that it hosts, for example, using sensors, actuators, and things like that. And what we want to do is we want to formally model such a built environment. The basic motivation for doing this is that there is a requirement for formal modeling and studying such aspects. And there has been prior attempt to do this, there has not been a cohesive model which captures the various facets of cognitive building in unison using a same meta modeling framework. And that is what we are trying to do. And what we're trying to do here specifically is to have a tower of informatic models. And each of these models is a formalism, which caters to a very specific aspect to model the building. And these models are related to each other in a very formal sense, using the notion of category theory. And a tool, along with a programming language, which can be used to apply this modeling in real life scenarios. So I would like to start with what bigraphs are. If you look at bigraphs from a mathematical perspective, the first definition that you will get is a bipartite graph. But we are not talking about a bipartite graph here. What we are talking about is bigraphs in this sense, wherein the top, this is a bigraph. And why it's called bigraph is because it has got two components. One is a forest, which is basically a group of tree, and other is a hypergraph. Now, this forest models the notion of containment. So, for example, a building has a room has a computer, and things like that, right? And this hypergraph models connection. Okay, so this computer can be connected to that computer, which may be in some other room. So it models two distinct notions in a single structure, so as to say. Now, so this is an example of a built environment. So here we see that there is a building called B, within which we have two rooms. Within each room, within this room, we have got an agent called A, which is connected to a computer called C. There is another room here. Again, we have an agent here, and we have a computer here. And both of these computers are connected through a network R. And there is some room somewhere else, which is not a part of this particular building, but all these agents are communicating with each other, right? So this gives you a structure or the space, as you would like to call it. Basically, you're modeling the static aspects of the cognitive environment. Now, where does the dynamic part comes in? The dynamic part comes through what is called as reaction rules. And these are rules as to how this graph can be transformed, right? So you can give specific rules, like, for example, an agent can enter a room, okay? So the agent was outside the room, the agent can enter this room. And this, when applied to a modeling environment like that one, so this graph here transforms into something like this, right? So here, this is the before, and this is the after. So when you're modeling this, what you're trying to do is that you're giving a static representation of the concept that you're modeling, and you're providing reaction rules as to how the system evolves, right? The other thing that you can do is basically compose things. So you can model smaller things. And because it is based on category theoretical concepts, you can compose these models together to form bigger models. So here you're seeing that there is a subsection of this model, and there is another model here, and both of these can be composed. And the way to compose is that you join links here, and there are gray areas here which are called sites. So this goes into this goes into this, and all the links join together to form a bigger model. And there is a mathematical notion of composition here, because the interfaces of the bigraphs have to match and things like that. But we are not really going there. I want us to understand the intuitive view first, and then we can go into the maths if required. So this is the composition here of this is basically how bigraphs can be composed. And the idea is that you can make bigger models from smaller models, right? There are other operations also in bigraphs, which you see. So you have to look at it from an algebraic point of view, in the sense that it defines a very rich algebra, and it has his history in process algebraic notions in computer science, like CCS and pi calculus and so on. So it's something like this, that you have got a set of numbers like integers, and then you have got operations like plus and multiplication and things like that. Similarly, you have got bigraphs, and you have got these operations to combine bigraphs and divide it, so on and so forth. So bigraphs has a rich anatomy. And the other thing that you can do is, one way to represent bigraphs is this. That is a graphical way. But there is another way of representing bigraphs, and that is through equations, right? And the advantage of doing this is that a computer can understand this better than the graphical structure. Okay, it's just like, I mean, if you want to program using a biographical reactive system, you can have this as a language which represents this. So this has a room full, which has got a room within which we have got an agent and a computer. So things like that. So you can represent that using scripts. So when we talk about biographical reactive systems, we have got bigraphs that represent the statics of things, and reaction rules through which you can specify dynamics. So it's just not, I mean, bigraphs have been used to model a lot of things, like, for example, giving semantics to programming languages in computer science, biological systems, right? Network protocols, and a lot of other things, right? So this is basically a meta modeling framework that we are doing. So why we are doing this and why is it interest to this particular community is that the existing formalism to model a building is that of BIM, right? But BIM alone cannot be used to model dynamic aspects within a cognitive building, because BIM can do the structural aspects of a building, but to do dynamic aspects of a building with respect to which has maybe sensors, actuators, and things like that, you need to have mechanisms on top of BIM which can model those behaviors. And that is where this work comes in. So the first thing that we proposed was a model called actors at BIM. And the act between actors and BIM is that these actors are within a BIM model. Okay. And the big picture of this is that actors are basically, again, a model of computation. So for this community, we can think of actors as a block in Rhino, which has some input, it processes it, and it can give some output, right? So these are basic models of computation through which you could design systems. It has got certain formalisms. It has other aspects to it in the sense that an actor can create another actor. An actor can manage another actor. And you can send messages between different actors to perform different kind of things, okay? So the actor in this particular model of actors at BIM are responsible to model the sensing, computing, and actuating aspects of the cognitive building. And the BIM is basically for the structural aspects of the building. And what we have achieved is that we have been able to use biographical reactive system as a meta modeling framework to model both actors and BIM in a cohesive way, so that the sense, compute, and actuate, or the cyber aspects of the system, are being managed by the actor model, and the BIM or the spatial aspect is managed by BIM. We are not tied down to BIM. It could be any other formalism that we could use. It could be things like space syntax or any of those things. But we started with a very small building level arrangements to understand how things will work for us. Now, the actors at BIM is basically a hierarchical model wherein we are able to derive modelings for specific devices like sensors, actuators, to a level of digital twin, which represents the entire building in its entirety. And this was the work that we presented last year, in the last edition, I mean. Okay. Now, how the BIM layer comes in is that we have a BIM server wherein the BIM model is placed, and we have a BIM actor, BIM query actor, which integrates very closely with the BIM server. And it can change the BIM model to some extent by using custom tags. So for example, if there is a room within the BIM model, and we want to say that, okay, the temperature of this room is 5 degrees centigrade or maybe 20 degrees centigrade, we can use some custom tags, and we can set that the sensor has sensed the temperature of this particular room at this particular degree centigrade, so on and so forth, or whether a door is open or a door is closed, what is our arrangements, things like that. So all these are using the BIM query actor along with the open source BIM server that we had used. Now, this is not the first time that bigraphs have been used in such kind of a situation. There's an earlier work wherein the actor model and bigraphs, which were representing space, was used, but they had used different semantics. So they had used structural operational semantics for modeling actors and the biographical semantics to model space. But engineering tools on two different type of semantics are different, and what we wanted was to have the same meta model to model both of these. There was another work which was more towards how BIM and bigraphs can be transferred. So given a BIM model, how do you transform into bigraphs? But here, the notion of an agent was not very clear as to what the agent would do. So the extension to this work was that we have formalized what an agent could do specifically with respect to the actor model of computing in computer science. So basically, we augment BIM with, so what actor model basically achieves is that it augments BIM with sense, compute, control for cognitive building use. Now, the actors at BIM model, as of now, could not model safety. And that is what the extension that we are proposing here. And what we are trying to do here is that we are trying to incorporate dynamic fault trees, which are formalisms to model safety within this particular framework. So this is the notion of static fault tree, which is basically a precursor to dynamic fault trees. And what this basically tells you is that there are two kinds of gates, the AND gates and the OR gates, which says that, okay, there can be ignition if there is smoking or sparks or a short circuit, and the probabilities of them are given below. And the ignition happens only if there are combustibles and the fire is out of control and there is ignition. So you can actually model the safety scenario using static fault trees. And this is a probabilistic model. And what you try to find out is that what is the probability of the plant burning down. Okay, this could be used in buildings. This has been used extensively in automobile space, wherever safety is critical. But this could not model certain aspects like temporal failures or things like, in bigger systems, there are always spares. So for example, if there are, a server which is acting as, within the cloud, you may have more than one server. So if one server fails, the other one takes out. So all these redundancies and things like this could not be modeled using static fault trees. And the things evolved to what is called as dynamic fault trees. And in dynamic fault trees, what we have is we have more number of gates, which can have things like sequential failures, which can model spares, and we can have things like functional dependencies and things like that. So basically, functional dependencies means that if there is a trigger event and there are other events which are auxiliary to it, if the trigger event fails, all these events fail. So something like, for example, my computer is connected to this particular power plug, and if I remove the power, the system can come down. So that could be a trigger event. So modeling all these kind of things is what dynamic fault tree does. And what we have done is that it's not the first work that models dynamic fault trees, but our contribution is here. We give a new representation of dynamic fault trees using biographical reactive systems, and this is for the first time that this has been tried. There are other formalisms that has been done to model dynamic fault trees. But what we are trying to achieve is that we are using biographical reactive systems, and we are using a set of different formal models, which the biographical reactive systems is able to model. And we are combining these models to form newer models. So for example, here we have BRS, which models BIM, which models actors, and which models dynamic fault trees. And what we can do is we can combine these kind of models to form actors at BIM. And then going forward, we can have more such combinations. And these combinations are also formalisms. And they have a deep-rooted structure in category theory. So you can combine actors and dynamic fault trees to say how faults are being transmitted from one gate to another and things like that. You can model things like ontologies. So what happens is that we have got a set of models. It's not just one model that is targeting the cognitive building. It's a set of models, each which is being specialized for a very specific modeling exercise. You are combining them such that the tools at the topmost level, which has been the tools, the results, and everything that has been researched at the topmost level can boil down to each of these derivatives. And this is the advantage of the biographical reactive system as compared to other formalisms that has been kind of considered before. Apart from this, we are also worked in a tool which is called Big BIM, which is basically a modeling mechanism. And there are some extensions to this from the previous work. So what this basically does is that you can take in a BIM model, which is in the IFC XML format, and there is a BIM to bigraph converter, which uses building ontologies like bricks and others, and the building smart dictionary to convert an IFC XML model into bigraph. And from there, you have a modeling language called BLang, which is basically a domain-specific language for designing biographical reactive systems. Now, there are two languages which are derived out of it. One is actors at BIM, and the other one is DFT, which can be compiled back to BLang. And from there, you can convert it into a notion called into a language called Prism, which is basically a tool to do probabilistic model checking. So what is model checking? So model checking is used to find out if now how are software tested? So you build a software and you have a testing team which tests, but the way testing works is that a tester will tell you that a system has a bug or not. He or she can never tell whether the system is bug free, right? So formal modeling is a mechanism which is used in safety critical system through which you can prove that your model is bug free, right? And the way you do is that you have a modeling language which has got a very strong semantics in terms of how things behave, which is mathematical, and you convert that into something called as a label transition system. And this label transition system is basically a set of states and how these states can be arrived. So it's similar to kind of reaction rules that we have in bigraphs. And then that can be analyzed through a tool called a model checker using logics like linear temporal logics and others. And what the model checker tells you is that whether a property that you're testing is satisfied or not. So if you can test whether my system has deadlocks, for example, or other properties, whether a door will open within 5 minutes of a fire, things like that, right? So the model checker will evaluate the state space, and it will give two results. One is whether the thing is satisfied, or if there is a violation, it comes out with a counter example as to where things have failed. And then you can go back to your design and then change it. And you can do this in an iterative fashion till things are successful. So this is the domain specific language which is there. And this is ID agnostic. So this is Eclipse, this is VS Code. And there is a diagramming extension to it also using Sprotty. So you can have a biographical reactive system, the sample, diagrammatic representation comes on the left-hand side. You can change the diagrammatic representation, the code automatically changes. And this has got verification support for Prism. So if you want to look at and you want to place this within a framework, this is the framework that we are using, which is called Viewpoints, Formalism, Languages, and Tools. So basically, we have got viewpoints. Viewpoints are basically pain areas of the end users, and which are supported by some kind of formalisms. And these formalisms are implemented by certain languages and tools. So for cognitive building, these are the viewpoints that we have covered till now. This can still be evolved, and that is where we are looking for collaborations. So the viewpoint of building geometry is covered by BIM. The modeling of cyber-related functions are captured within actors and BIM. Safety reliability aspect is captured within DFT. And all these formalisms are meta-modeled using biographical reactive systems. And then there are languages and tools which works across these particular formalisms. So these are the future work that we plan to do. We would like to consider other formalisms, specifically space syntax and others. We would like to explore how do we put in ontologies into it, because ontologies also has these kind of structures so that agents can, we give a formal mechanism for agents to reason. And we would like to extend the language tool suite and focus more on the graphical domain specific modeling aspect. So Thank you. Should I be closing this or?
So the second paper, it's named Formal Methods in Flood Disaster Response, the case of Porto Alegre in Brazil. It's by Ana Paula Dalcin, Camila Pezica, Clarice Pereira de Souza, Diego Altafini e Guilherme Marques. I'd like to invite you to come here and present your paper.
I'm here already.
Oh, you're here. I was supposed to.
Don't worry. Thank you for the presentation.
Oh, yeah.
So presenting myself, I am Diego Altafini. I am a Marie Curie Fellow at the Welsh School of Architecture. And as presented, I will present you a bit about formal methods in flood disaster response and the case of Porto Alegre, Brazil. So climate change is increasing the recurrence and severity of floods and extreme events, especially in urban areas, such as those we had throughout Wales and England in the last week, as we had in Valencia, Spain, and as we had in the case that I will present to you today. So in May 2024, torrential rains have drenched the state of Rio Grande do Sul, Brazil, and triggered the floods, worst floods in 80 years, which affected 91% of the municipalities of that state. This rainfall was so intense that it surpassed in 48 hours the 500 millimeters, meaning that we had columns of water of more than 5 meters on some places. These floods displaced more than 580,000 people and really disrupted the road circulation network on between the state capital and the metropolitan region, and erased from the map cities, entire cities. So just to give you a dimension of these floodings, here we have a Sentinel-2 image from 18 April, and this was the state after the floodings, after 8 May. The interruptions on the road system posed a very difficult challenge for the coordination of the relief services due to the multi-scale collapse of the road network system. In that aspect, the formal methods of architecture, such as configuration analysis that interprets roads as graph networks, played an important role in conjunction with other knowledge domains to actually provide actionable information to the stakeholders and to the responders to cope with this crisis, as it's described the system performance before and after. So this presentation will provide an account of these efforts that we were involved at Cardiff together with people in Brazil, and demonstrate the performance shifts in terms of relative accessibility and preferential routes within the Porto Alegre metropolitan area. And we will also showcase how we communicated these results as a decision support system pilot, which was co-designed with both local researchers and through the engagement with the local authorities. So we could actually showcase the important aspects of the models themselves. So just to introduce and provide an overview of the analysis area and the conditions where it's stable. This road network graph derives from OpenStreetMap. It's the base of comparison among all the scenarios that we established. We established 4 scenarios. We'll go in detail later. And this represents the extent of the most affected urban area from the floodings. This map was generalized to remove those elements, those road elements that were deemed as, I mean, not unsuitable, but that might distort the actual analysis, because those were or flooded preemptively because they are unpaved, or are rural roads that do not are usually not used in these kind of accessibility models, as they would be blocked anyway due to the rain. And here I can showcase you the most important access. So we have several roads that are considered highways, especially the BR 290 and the BR 116 and the RS 180. Those are very important axes of structure, as you can see within the system. This is what we call scenario 0. We have 3 scenarios post-disaster. This is the scenario 1 that represent the road conditions immediately after the floodings. So from before 6, in fact, to 8th of May. We consider 6 because the flooding mark was validated for the day 6, for 6th of May. And you can see that we have several interruptions, but here on the bottom, so all the roadways of the BR 290 are cut away, and up there we have the cuts on BR 116. Also, several access between Porto Alegre and this northern part of metropolitan region were severed, and towards both northeast and southeast. These blockages create 3 independent systems, as we'll see later on. In scenario 2, we simulate a hypothesis of the RS 180 interruption and the total collapse in terms of connectivity between the southern and northern part of the metropolitan regions. This would result in 4 independent road networks. And this was a very important risk because that roadway was within the flooding mark, but was a bit elevated. So if the waters rise another meter, probably it would lead to the general collapse. So that area was very important because, as you see, is the only connection. And it needed interventions in terms of safeguard of the whole structure. And we have scenario 3 that is after 10th May, that represents the emergency corridor opening. So we reconnect the center of the Porto Alegre city towards the rest of the metropolitan area. Because the problem was this area here is left inaccessible in the scenario 1 because we had interruptions here and no other access towards the other. So the emergency corridor was made around here and relinked the elevated highways that remained inaccessible in the regional or in the initial part of the disaster, right? So there is the emergency corridor. It's added a bit of redundancy to the system, right? Each system scenario is modeled using angular segment analysis, a methodology from Spain syntax for the measures of normalized angular integration and normalized angular choice. And we go to describing a little bit of these measures right now. Well, normalized angular integration measures the relative accessibility from a road element toward all the others in the system. Therefore, it gives us the dimension of the movement potentials within that network. This at radius n. When we use metric radii, those denote the local relative accessibility that can be associated to certain transport modes, depend on the radii, such as pedestrian and vehicular, and measure the movement potentials at those scales. The other measure, the normalized angular choice, measures the number of times a certain road element is traversed to reach all the others within the system, thus indicating what are the preferential routes for moving from one part of the system to the other. And of course, the probability of flows within those roads. At the local scale, it more or less indicates the same thing, but also in terms of neighborhood scale and associated to certain transport modes. Well, onto the results of this analysis. In total, around 12.8% of the system was flooded. Despite this doesn't apparently to be much, it's a low percentage, it's just a bit more than 10%. This interruption caused a very noticeable drop in the system performance in now post-disaster scenarios, especially regarding relative accessibility. So here we can see individually the scenarios, and we can have a more precise dimension on what this occurred. So in scenario one, we had the greatest loss in terms of road network performance when we consider especially system-wide relative accessibility, so 9. And the average values dropped to 48% of the stable system. The stable system is the black bar on the top that represents the 100%. So every system is related to that one in terms of average 9 distribution. In scenario 2, we had a lower decrease, but as we soon observe in the maps, this is due to the relative accessibility patterns concentration and not an actual better system performance. Because since we have 4 systems and those systems concentrate the relative accessibility in themselves, they tend to be higher in that aspect. Scenario 3, which would be the scenario with the development corridor instead, we actually have a real improvement of performance with the connection of the emergency corridor. Okay. So how these results are translated spatially? First, let's start with an overview of the stable system. You can see that the movement potentials are even distributed between north and south. We have the centrality core, which is the red road elements, well distributed among all the municipalities of the metropolitan network, and we have 5 or 6, if you count differently, connections between both east side municipalities and north side municipalities, right? So the metropolitan system is established within the 6 points of redundancy. When we have the interruptions, you can see that there is a devastating impact on the movement potentials across the metropolitan network, which especially affects the Porto Alegre city center. You see, it basically erases the high accessibility that we had there before. This is caused because we lost basically all of the accessibility points within the road circulation network, the highway network. So the only one remaining is the RS 180. This greatly affects this region because especially those areas that flooded both here and here are also the areas where we have a very high concentration of a low-income population. So besides being a network impact, it also had a very big social impact. Moreover, another thing that is important to point out is that this region that was flooded is the Porto Alegre airport. So the Porto Alegre airport was flooded and we could not receive relief efforts through here. The only airport that was working is located here and is the military airport. So imagine that to the relief services arrive at Porto Alegre, they would need to cross the RS 118 and go throughout all the system like this. So it was a very difficult effort in terms of relief and such. So regarding the northern areas, the only access remainder was through the RS 020, which is the one that is highlighted, and it segregated the whole northern area. So access towards these areas here was way how can I say, the access was very impeded, as we can see. So you had to basically do all that route to arrive there. So it remained really segregated just because of the interruption here and the lack of redundancies. And moreover, the municipalities of Montenegro and Guaíba were isolated from that system, so we could only access them by boat and provide relief services by boat. And the municipality of Eldorado do Sul, which was here, completely disappeared because 100% of its road network was flooded. So basically, they were hanging on the 2-story buildings. Well, scenario 2 works with the hypothesis of the cut out RS 180. So you see that we form 4 different and contained systems. The relative accessibility increases in terms of performance because Porto Alegre becomes its own system, right? But in the end, it becomes isolated from the logistical hub that is in the other side of the river. In this sense, you would have to go more than 100 kilometers through two roads on the bottom to be able to arrive from there and there, because the only access is towards the seaside areas, the coastal areas, which it's rather far from Porto Alegre. So in that part of the system, we could even not model it because it will probably be irrelevant in terms of relative accessibility between those two places. It's too much of a distance. So one thing that we must consider in that aspect is that small disconnections can have a very big impact on the relative accessibility. So as you see, it increases on other parts, but it decreases in general. So also you can see that this scenario is very close to the 5 kilometer scenario. Basically, both these two systems become local, so and not function as a global entity anymore. Well, in scenario 3, we inform how the system actually improved with the inclusion of the development corridor, because we can see over there that it becomes very similar with what we had before, especially between Porto Alegre and the middle part of the metropolitan region. Of course, the northern parts continue to be segregated because we do not have other redundancies to connect there. So there is that. So the emergency corridor tends to improve the system. This was the emergency corridor, so it connected that part, which was pretty flooded, which I think it has more or less 1.5 meters of sediments that were used to make the emergency road. It improves the movement potentials in general and the linkage between the Porto Alegre area. So the system-wide impacts in preferential routes tend to be more limited in general because of the probabilistic nature of this measure, and that the hierarchies tend to be maintained despite perturbations in the network. In this case, the performance improvements or deteriorations are dependent on the elements that are disconnected and do not impact in the system-wide movement as the relative accessibility measure, right? So all 3 scenarios remain pretty much similar in terms of what are the preferential routes in that aspect. So restoring one of the preferential routes, of course, will give the system a bit more of life or more of performance in that case. We could see even in the graphs that they were pretty close in terms of general performance. And well, so how these analyses were used to decision support? In the context of post-disaster, we engage with different figures of the public sector in Porto Alegre to communicate the initial results, because these analyses were made between 1 and 3. So in the very early beginning of the disaster. And to showcase, well, how it affected, right? How these analyses can help you. And we actually interface with them to see which were the most critical issues that were, of course, guaranteeing the access to relief efforts. So guaranteeing the north and south accessibility, right? In that sense, we created this communication, which was distributed to the high-ranking officials that were informed that they needed to all costs preserve the connection between the two. After that, we did the technical note. And recently, we made another communication showcasing the whole analysis that was used to also create this paper, right? So to finish this presentation, some concluding remarks. This was a showcase of how the formal methods can be instrumental to support decision in the context of floodings, which can also be transferred to other kinds of natural disasters that affect specific urban areas. In specific, the configuration analysis is a great asset, providing an overview of the network conditions that impact both accessibility and routing, which are crucial to relief actions. So these scenario-based comparisons, especially found on cartography, allow non-experts to quickly understand the criticalities and raise their awareness for the impacts on decisions to be made. Yet there are a couple of challenges in that, especially regarding computational demands that still limit the real-time application of these formal methods in larger scales. These models took 3 days to be made, and 3 days in that context is a lot of time. And furthermore, we need to have a more tailored decision support framework, as communication of these results need to reach non-experts. And these decision support systems need to be outcome driven or need to be tailored to their understanding. Otherwise, they will not act on this information. Thank you for the time. Sorry to have a little bit abroad time.
So, for now, for a period of questions and discussion, I would like to ask you to join us. So we have these two very different. No, the first one is not come.
Okay.
Yeah, so. So these are two very different papers with one basic topic, which is fire and water. Yeah. So I'd like to ask if anyone wants to put some questions.
I'd like to ask a question to Gobin. I was specifically interested in you present this framework with the different models. You have the BIM model, the actors model, the DFT model, and then you combine them. And maybe you could shed a little bit more light on how you combine them. Is this through hypergraph, or I mean, how do you integrate the different models?
Yeah. So the integration happens. Yeah. So the integration aspect happens at two levels. One is because we are using the same meta modeling framework, we are able to model this using similar building blocks. So one integration is at that level. The other integration is more at the category theoretic level, wherein we use things or notions like refinement. So there are notions in category theory which talks about horizontal and vertical refinement. So if you look at it, these models are basically specializations of biographical reactive systems. So they are like a vertical descendant of biographical reactive systems. So they are like a vertical refinement. And if you look at things like actors and BIM, right, they are like horizontally apart. But you can use the notion of composition in category theory to compose the actor model within, something like BIM. So the notions from category theory comes very beautifully into this, because the advantage is because of the meta modeling framework that we are using, which is biographical reactive systems. And it has got a very strong background in the category theoretic framework, specifically because it forms what is called as a symmetric partial monoidal category. So because of that, this is something which is inherent that we get out of. We get out of it fairly easily. Yes.
This is also for Gobind. I'm wondering, how are you planning to validate the model or the actors?
By validating, you mean what exactly?
Or
Oh, okay.
regarding-
if you, the paper has got examples of validation. The validations that we have used is specifically validating the biographical reaction rules with respect to the expected behavior of the dynamic fault tree. So the dynamic fault trees have got, so dynamic fault trees are a set of gates, right? So like a priority AND gate or a sequence gate and things like that. They have got a specific behavior. What is there in the paper is that how those behaviors are being captured using biographical reaction rules and a formal verification mechanism, which formally verifies that indeed the representation, the biographical representation follows those rules. So that is one level of validation formally, which is presented in the paper. But what we are interested is basically how it can be used within this particular community. So the validation from the users is something which we are more interested in.
Thank you. I have a question for, or maybe a comment or a suggestion for Diego. You looked into the impacts of a disaster that sort of cuts off connections. And now you focused a lot on the integration and choice values that are used in space syntax, which are important to understand flows and important to understand, let's say, centralities and activities that will take place. But maybe it's not so problematic if actually temporarily you have let's say, it's kind of a segregated system or 4 systems, as you said, that are working in themselves, if the main services are still accessible, or if the distance to those sort of crucial services, let's say hospitals, or let's say are still in place. So I would suggest actually to add, because you have the model, to add accessibility analysis to those kind of crucial, that the stakeholders can help you find, let's say, the crucial services.
Yes.
And see how, let's say, what is the increase in distance to those. And then you can also add, if you have the data, the magnitude of, let's say, the amount of people that are actually impacted by that. So you get a kind of another understanding, because maybe actually, yeah, one bridge or one road that disappears, if you can take a detour, yeah, the system is kind of not so well integrated anymore, but that's not a problem for those 2 weeks, let's say, that you're living after the disaster, if the distances are not too big and if there is still accessibility, etc.
Okay, no, this is an excellent suggestion. They actually did this on the grand scheme of things, because we supported an effort that was multidisciplinary, that was conducted by the university in Brazil, but they didn't have the expertise nor the time and nor the computational power to actually model those data sets. So they actually did the accessibility analysis on their side. We focus here on what we did. That's the main thing and the main take that we had on this paper. And do not also focus it on all things we did, because we also did the redundancy analysis using the methodologies of Valerio, basically. But we did not include in this paper, as it will be too much, because this was an effort that resulted in more than, I don't know, I think it was 42 or 43 maps, counting all the scenarios and all the analysis. So it was impossible to actually present them on the paper. But they actually did both relationships with the populational analysis, the demographics, and it will be published in the next paper that we are still working on with the people in Brazil. And they did cross those data sets with both the temporary shelters, both with the hospitals and the schools that were used as temporary shelters, of course. So in the end, there was this crisscrossing, but we just do not focus it on this work. On the thing being temporary, well, this is a bit of a stretch to say, because in the end, the situation was normalized around June. So it took more than a month basically, to actually return to the stable system. So it was a pretty much ongoing disaster. But thank you for the suggestion. I think it's very interesting, and we should have a look also in publishing those results.
It could also be, let's say, maybe you should compare then these results. Is it a kind of a good indication that your analysis gives, that you don't have to do all the other ones, to sort of find what is the minimum of set of analysis to get a good overview of
Yes.
what are the consequences? That could be also a next step if you already
Yes.
did
Yes.
all the other ones.
Yeah. In terms, sorry. You can continue. Sorry.
No, I don't have more
Okay.
questions for you.
No. In terms of local, that's why I didn't even show the local maps. In terms of local, the system was not affected that much because we have a rather contained, how can I say, flooding towards the residential areas. Not that we're not actually affected the areas that we had the concentrations of services in Brazil and in Porto Alegre in general. The great problem in that aspect there was the airport, because when the Porto Alegre's airport was flooded, we could not land the planes with the relief aid from outside. And getting the relief from the coast, the seaside of the state, it's a very big endeavor because it's more than 120 kilometers. And there are actually roads that were unaffected in terms of, how can I say, general blocking, because this was the area that was most affected. But as I said, 91% of the state was affected in some way or another. So we had blockage throughout all the state. It would be very interesting to actually model the whole state system. But as you understand, this is a computational impossibility almost. But again, thank you for the suggestion. I think it's very useful, and we'll look into it for sure.
Very well. So does anyone else wants to make a question? No? Okay, then thank you very much to the authors. We're going to start with the other section. Yeah. So we're starting now section 9. And the first paper, it's called Relight Spaces, Training Daylight Access Cognition in Combinatorial Spatial Assemblages Using Reinforcement Learning by Alessio Erioli e Giuseppe Massafra.
And assemblages by guaranteeing a minimum of solar exposure on the total resulting spatial systems. The background of this research moves beyond different methods in architecture, above all a combinatorial design in which we see architecture as a system made of parts, and that with their aggregation make a system of different meanings and spatial types. A part important in the combinatorial design in this research is the induction design, in which we try to let that the aggregation process is linked with the fixed design criteria related to the environmental and climatic data. We use in this research deep reinforcement learning agents, trained agents, To introduce the reinforcement learning, let me do this simple example. So when we want to try to ask our dog to accomplish a simple task like to sit, what we do is to go to the park and try to ask him to sit. And whenever he does this action, we give him a dog treat. So during a training session, our dog will understand the association between what we ask him, his action, and the rewards he gets. So during a long training session, at the first, the dog maybe will be a little confused, but going over and over with his experience, he can learn a determined task. So in reinforcement learning terms, we call that dog is an agent performing action into an environment, and an environment that give two type of feedbacks for his action. Rewards are information on the effectiveness of his actions, and observation are information about the state. So, for example, our vocal command is an observation that says to the dog, the environment is asking me to do something. So with the experience of the agent and with the rewards, we can shape a way to let the agent learn a strategy to automate decision to accomplish a determined task. In my research, an agent was capable of doing action into a simple voxel environment to build up assemblages made of a predetermined number of parts. At each step, we analyze on these assemblages two types of data, one related to the climatic and sunlight condition on the assemblages, and the other on the topological information, so how the parts are related into the assemblages. And according to this, we give the agent rewards in order to construct assemblages that could have a predetermined number of predetermined lighting conditions. So this is our environment, a voxel space. The agent can move throughout different cells and place a variable number of parts. And in response of his action, he receives information about the state of the environment. And this information are topologic. So these topologic information are related to the state of his shell, so full or empty, on his position into the three-dimensional grid. The other information are related with the climatic observation and are the sunlight condition when we want to arrive at the final of this process. So when we generate an assemblage, and the sunlight condition that are lighting the assemblages at that iteration. So we use as factor of daylight this direct sun-hour analysis, which tells us about the number of hours in which the normal of his surface of the assemblages and the angle between this normal and the sun position is in a range of 45 degrees. So we have this data for all the surfaces and condense them into an average value. So at the beginning of the process, we say a target number of hours that we want to maintain on the global assembly and let the agent do perform its tasks. The reward function is the part in which is the most difficult. Because we have to translate into a mathematical function what will be the agent tasks. So we give step rewards at each iteration to the agent, and so you get more rewards, more the topologic. Can I say the configuration of the system is topologically as a topologic coherence, and more the lighting conditions meet the target condition wanted at the beginning of the process. Then there is a final reward given at the last iteration to let the agent understand when he has completed correctly his task. All this process is made by combining RL algorithms in Python with the Rhino and Grasshopper environment and using Ladybug tools for the solar and environmental analysis. What we do at first was to train different models to perform actions and build different assemblages and map all the progress into this spider graph where the green areas represent the cases and the assemblages that meet our final goals. So at the beginning of the process, we have this situation with assemblages that were far away from our goals, both for the shape, the connectivity, and the density of the parts, that it's evident that there is a lack of organization, and both from the climatic perspective, the lighting conditions are far away from the predetermined ones. So we try to improve our reward function, trying to simplify that and pass from another model in which the performance were way better. And both because we obtained some interesting assemblages, both from their connectivity and for topological coherence, and both because climate requirements were meeting. So at this stage of the process, we have a model capable of understanding, have a connection of the environment and the data that we are analyzing in this process, and capable of constructing assemblages just starting with his experience accumulated during the training processes. But at this stage, we had a problem because for the nature of our observation space, the model is not scalable. It's just relegated to the spaces or environment of these specific sites. So what we did was to simplify the observation space, the information that the agent gets from the environment, and now just with the local information about topology, so the agent just knowing which is the state of every neighbor, so the cells near its position and global climate information, can accomplish its task in a very different kind of environment in terms of accession and in terms of the number of parts that build up the assemblages. So this in this part at this stage, we ended and completed the model validation process and tried to increase the level of constraints into the environment, introducing two types of obstacles. The volumes in gray are blocking the sun, whilst the volumes in blue are cells where the agent cannot enter. And then we tried different configuration, both for the obstacles layout and for the sunlight condition targets, just to prove if our model were capable to adapt to different scenarios. So we test it into different assemblages and configurations, and tried to extract some data to understand how every environment is related to the final shape of the assemblages. And we extract data for a circulation of the internal circulation of the assemblages, the density and the footprint of every assemblages. And above all, we focused on the gap between the lighting, the target lighting condition and the actual lighting conditions that we analyzed on the assemblages surfaces. So in conclusion, this process, this research highlights one of the possible role that reinforcement learning can play in integrating climate and environmental data into a design process and how automate them. And of course, it's led to a broader discussion on how can we use data to and climatic environmental data to shape our environment and how they are related to the architectural qualities of our spaces. And were encountered several limits because the pipeline that we developed was not that much fast when we tried to develop and generate assemblages of several number of parts. And further develops sure will take into account an higher level of detail. Of course, in this research, we maintained a conceptual and simple design into the components, but it could be interesting to investigate how can the agent can construct in a more detailed manner these assemblages. And the last is one of the most important is to extend the model connection of the environment to other climate factors, not just to increase the complexity of the system, but could be very important to let the model learn a condition to environment that are more similar to the complexity of our reality. Thank you.
Thank you very much. So we'll keep up with the reassembling waste towards a carbon zero built environment by Inês Caetano and Luís Santos.
Is this on? No? Okay, I think this is on. Thank you so much for being here. And thank you so much for accepting my paper, at least for this presentation. This is an ongoing research that I'm doing with my dear colleague Inês Caetano here in Technical. While I'm in, although from this latitude, I'm in Aalborg University. And the title of our presentation is Reassembling Waste Towards a Carbon Zero Built Environment, and why this is so important. Because you probably already saw these graphs over and over again, but 37% of the carbon emissions or carbon equivalent emissions is related with the building industry. And there's a couple of similarity and correlation between also how many and what is the energy that we spend in the building industry. So tackling, if we want to achieve decarbonization of our societies, tackling the decarbonization of the building industry is quite relevant. So what are the solutions out there? First solution is the radical solution, which is minimizing building activities, construction activities. So we should probably transform our building stock, adapt our building stock to increase intensity use of our existing building stock, particularly in Europe, because we have demographics that are shrinking. Although geographically it's a more complex issue because a lot of people want to live in cities, but our building stock, we have a lot of building stock that is not being used at the most. The second solution is optimizing building and construction processes, such as energy efficiency, use low embedded carbon materials, such as bio-based materials, or then design for last. So if we are going to use a lot of carbon to make a construction, let's make that construction to last for a long period of time. A third approach is circular design, very popular a couple of years ago, such as design for disassembly, because it will facilitate the reuse of buildings and building parts, such as materials and components. But this reuse of building materials and material parts and components could also be linked with upcycle. That's why I'm addressing waste. All of these solutions are not self-exclusive, so they can work together with each other. My research, or the research that I did with Inês here, is going to look at upcycle of buildings, materials, and components here. Why? Well, in 2025, it is projected that construction waste will achieve an annual rate of 2.2 billion tons. So, in a period that we have scarcity of resources, just not tap into that scarcity of that huge resources would be, sorry about the redundancy, a waste opportunity. So, and architectural practices are already achieving this or looking at this. So we have a couple of examples, such as the, sorry if I'm going to mispronounce this, Villa Welpilu by Superu Studios in the Netherlands, and the Open Air Library by Kado Architects in Germany. But if you look at these buildings, they do not show, or their tectonic expression, actually, it's not linked with reusage of materials. It seems that they're quite normal buildings, although they are upcycle building waste materials. Probably the current office that is doing a lot of work in terms of upcycle building waste materials is the Leninger Group in Denmark. And this is probably their most emblematic project. It's called Resource Rose, which was using a huge building stock that would be demolished in the Carlsberg quarters or districts of Copenhagen. And here you see that it is an assemblage of parts. We might say that this is completely new, or it's in a new paradigm. I might point a question mark here, because we are revisiting what late Roman Empire like folks were doing with spolia, and also early medieval time with spolia, which was reusing or tapping into the built environment as a material resource to make new buildings. So we are, again, revisiting and using that same strategies over again. So what is our research goals and hypothesis? It's to explore ways to facilitate the upcycling of building demolition waste in the design of low carbon structures, promoting a discourse on waste utilization. So if we facilitated tools for architects to do that, we are popularizing these tools and facilitating architects to engage with these gigantic resources by enhancing performance-based design processes that integrate material circularity. Our hypothesis that we can achieve this, or the first step to achieve this, is to develop the computational frameworks that leverages computational design, cradle-to-grave life cycle assessment methods, and building energy simulation. So I will talk about the method that we use, or the methodological approach that we use, which will introduce this computational framework that we developed that facilitates the upcycle of material waste in design processes. Then the experiments that two small experiments that we did, discuss the results and conclude. So our methodological approach had three phases. The first phase is basically what I've been talking to you. It was a small literature review in order to identify current trends, gaps, and needs. The second phase was developing the framework, the computational framework. And this we use different methods such as algorithmic parametric design, search and optimization in design, and co-simulation by using tools that can perform life cycle assessment calculations and building energy simulation. Phase 3, we evaluate our framework to assess and test it if it's useful or not, using face validity tests. So if the results make sense or not, and if they will produce significant or relevant outcomes to design. Just a glimpse, if you are not very familiar with life cycle assessment. Life cycle assessment is an approach that stems out from industrial ecology, and it analyzes any type of product that is designed by humans and fabricated by humans, holistically from cradle, when we get the resources, the raw resources, transform the raw resources, implement the raw resources here, in our case in the building, then the operation phase, and then the end of life. So how do we decommission buildings and dispose of buildings? Lately, there's another phase that we are not very, there's a lot of uncertainty in that phase that is beyond the system, the typical beyond system boundary, which is phase D. So which is reuse, recovering, or recycle potentials of our structure. We are tapping into that because basically what we are using is other buildings waste material in order to make new buildings. Our computational framework is a modular one because it needs to be flexible, it needs to be used in different design scenarios, and entails the following modules. A disassembly module, which generates a material atlas from an initial material stock. A design module that allows architects to design and establish certain constraints to their designs. A reassembling model that will reassemble the material atlas in order to achieve a specific design. And a simulation model, which will tell or inform the designer about the performance regarding global warming potential. And by a note, sorry, I didn't explicitly frame global warming potential here, but you will see as an acronym, GWP. Every time that I'm talking about GWP, it's global warming potential. Basically is measured by kilograms of CO2 equivalent emissions. And also, and building energy performance as well, simulation model, and the search and optimization model, which allows to parametric and search and optimization of both energy and global warming potential. Let's look at the first module, the disassemble module. The heuristic implemented is quite simple. It departs by the fenestrations that you can find in buildings, and it starts slicing by using either horizontal cuts, vertical cuts, or a mixture of the cuts. When it cuts, it disaggregates or breaks the initial component into different parts and reassembles it into different types of material atlas. The design module allows architects and other designers to parametrically describe buildings or algorithmically describe buildings, depending on the way that you want to describe these buildings. It also allows architects and other designers to start structure the existing material stock that they need to use by giving a specific goal, such as a wind-to-wall ratio. Giving a specific goal, the algorithm that is implemented in the design module will make a stochastic selection of the existing windows in order to achieve certain patterns of design within the wind-to-wall ratio. Here, what is implemented is windows could be distributed linearly, windows could be packed in certain regions, or windows could be randomly distributed in a facade. An example, to achieve a specific wind-to-wall ratio, the architect defines here 2 areas where he wants to place windows. Those areas are adjusted to fulfill the desired wind-to-wall ratio. Given those areas, the algorithm places the windows, and then those in those areas will be constraints for the packing solution of the remainder material that we have in our material atlas. And here it's very colorful. Colors do not indicate different types of material. It just indicates different. It doesn't indicate materiality, it just indicates different types of material. And materials are decoded by material type and by dimension. This is the way that we encode typologies of materials. A couple of initial tests here with hypothetical material atlas here to achieve the same purpose, wall ratio 40%. And here the way that the algorithm allocates different wood panels, a mixture between wood panels and brick panels, and a mixture between brick panels and concrete panels into that facade. So this is the reassemble module, probably was the model that we needed to devote more effort to implement. Then we have the simulation model. The simulation model is basically a co-simulation tool. It uses Energy Plus by Climate Studio. Probably already know Climate Studio. It's a tool for daylighting and energy simulation for early stage design processes. Developed, stems out from the MIT research by Christopher Reinhardt. And here is Bombix. Bombix is it's a grasshopper front end for life cycle assessment calculations, and it is developed in ETH Zurich. It uses the Swiss database, which is basically very similar to the database that it has been used in Germany and also in Denmark. Then the search and optimization model can be used in two things: to inform the design model, to drive the design process, or also to optimize reassemblage usage. And uses of like Connect uses like Julia optimization package, and also native package that we can find, for example, in Grasshopper, and can use a wide variety of heuristics, from particle swarm optimization to genetic algorithms, etc. Here, what is important is that the designer needs to define an objective function that he wants to minimize or maximize, and also define the inequality and equality constraints. So, having set the system, we test the system into a design experiment. And we use the thesis, a master thesis that was produced in Aalborg University that was awarded, actually, got the awarded of the Sweco Transformation Award. And basically looks at the social housing, quote unquote, or social cooperative, because the terms are a little bit different in Northern Europe, that the government imposed because it was considered a ghetto, quote unquote. The government imposed that several buildings needed to be disassembled or needed to be demolished because the population, part of the population needed to be spread out to other social housing complexes. And this is the type of the donor buildings that we could find. The objective is to disassemble these donor buildings. And the aim for this speculative thing, design of experiments here, is to use our tool to design the facades of a 4-story office building to be inserted in the master plan developed by our students, which is this one. They share something in common and simplified because this is really the early stage or a prototype still, about like we established certain key elements that they will stay here in the outdoor wall. The things that could be changed would be the reused panel or the cladding and the insulation. There were variables here. And we already strive to have a wall assembly that is low, has a low global warming potential. The floor ceiling, they can just use reused or new wood parquet that could be found also in the material atlas. The ground slab, the insulation, it is a variable, and the roof, it is concrete. The ballast of the roof could be recycled and outsourced inside, and also the insulation will be a variable. So having this 4-story building with this envelope properties, we developed 2 experiments. First, it simulates a one-at-a-time iteration process that the designer can do. And here is 2 scenarios. I have a specific building mass, and I want to have a standard scenario, which is a window-to-wall ratio in the north facade and the south facade of 40%. And then the designer tests different insulation materials. with the objective of having an overall U value of 0.5 watts per square meter Kelvin. Then the alternative scenario, the designer tweaks the wind-to-wall ratio in the north facade and the south facade to optimize solar gains. Experiment 2 is a two-phase optimization process where the shape of the building, the width and the length, is optimized to reduce energy use intensity. So the length of the building, the width of the building is optimized. The wind-to-wall ratio in the north and the south facade is optimized. It can vary between these intervals here. The U value of the different envelope surfaces could also be pre-optimized. And those pre-optimized values will serve as constraints for the second optimization, which is define the insulation materials that you can do and also define the allocation of material that you have in the material atlas. The pre-optimization goal is to minimize energy, building energy, and the optimization goal is to minimize global warming potential. They are correlated, as we will see. So in the first experiment, the fixed one, the one at a time experiment, iterative experiment, these are the results. So here blue indicates where the windows are allocated by R2, and light gray, this areas here, indicates the usage of new material, which we decided to use oak wood cladding because it has a very low global warming potential. These two tables here indicates the distribution of the material between the standard scenario and the alternative scenario explored in this first experiment. And here we observe that the material distribution efficiency follows low global warming potential, as expected, because I'm using less material. I'm reusing more material, so I'm using less new material. Here we have the best solution and the worst solution. The worst solution is just using the extruded polystyrene as an insulation, and the best solution is using wood fiber. And also the best solution is the void area, so the inserted of new material in the facade is quite low. The reused materials, so the facades that could be applicable of reused materials only represent 20% of the total building surface area. So we could achieve more gains if we use more area where can we apply reused materials. Results, 70 to 85% of total global warming potential is due to operational energy. And this I will make a note, which is very important. The Danish energy system is already highly efficient, but nevertheless, energy operationality still is the biggest slice in global warming potential analysis. Regardless that Danish energy will be completely green, almost green electricity in 7 years from now. If we compare global warming potential across solutions, the different solutions, we could save 18% of carbon emissions. If we compare within the solutions, if we compare just by the same solution by reusing materials and using new materials, but the same materials, we can save 8 to 12% of carbon emissions. The experiment 2, so where we allow the system to optimize first for energy and then for global warming potential, we found that the system decided to maximize solar heat gains in the south facade, which makes sense, and minimize transmission losses through windows in the north facade. It also extended the building length in order to favor solar heat gains. Here are the results. It was less efficient in terms of material distribution because to optimize energy efficiency, it just generated longer facades. So the material outlets was not enough to fill up those facades. But the outcome of minimizing energy use in that building is compensated or offsets this slight inefficiency of material distribution. In terms of the two scenarios that because we run the algorithm twice, between the two scenarios that we run in experiment 2, the solutions are quite similar. So indicates the robustness of the system. The percentage of global warming potential within solutions by reusing materials and not reusing materials is around 8%, favoring the reusage of materials. If we compare this solution generated by using optimization with the solution of experiment 1, we improve 5% if we compare with the best solution and 20% if we compare with the worst solution in experiment 1. In conclusion, our framework leverage computational design, life cycle assessment tools, and building energy simulation to create low carbon buildings. It supports circular economy principles while allowing tectonic explorations. So what is the expression of reusing this type of materials? Of course, we have a lot of work to do still here. This was an initial exploration about this. It optimizes building elements reuse, energy consumption, and global warming potential. So it minimize energy consumption and global warming potential through maximizing building elements reuse. Limitation, allocation. Right now, material allocation is restricted to rectangular surfaces. We have a very simplistic heuristic of taking apart and building up material atlas. And we are using simplified construction principles. Why simplify construction buildings? I'm just going to go back here to my image. Imagine how is it to put relief angles to hold all of this material. So there's an extra step, relief angles to hold all of that cladding. So it would be a little bit complex. Future work. We want to expand more tectonical, structural, and construction considerations, such as the problem of the relief angles, probably model those considerations as constrained. There's still a big question mark here. Address multi-objective search and optimization procedures. We're just like looking at energy efficiency and global warming potential, which are very correlated. But for example, indoor environmental quality performance indicators, such as daylight, indoor air quality, etc., should be taken into consideration. And expand for mobilities and disassembly strategies. Thank you so much.
So thank you very much.
What's this?
So the last paper is entitled Optimizing Sustainability Through Digital Tools, Energy and Carbon Comparative Analysis of Brick, Concrete and Wood Frame Constructions in Coimbra Residences by Leonor Domingos.
Hello, everyone. So we know we're very close to the coffee break time, but we just ask you that you bear with us for a little bit longer. My name is Leonor. I'm an integrated researcher at ISCTE, and I'm joined here today by my colleague, Sara Pares, who is a PhD candidate at ISCTE as well. Now, we're here to present to you our article regarding optimizing sustainability through digital tools. And we are bringing you a comparative analysis of 3 different construction assemblies in terms of both energy and carbon. So as you all know, the Paris Agreement defined a maximum rise in average global temperature of 2 degrees Celsius above pre-industrial levels. So now between 2013 and 2023, we actually came up to 1.20 degrees Celsius above pre-industrial levels, which makes it the warmest decade on record. So we know that ideally we should only reach up to 1.5. We can still do it, but it'll be really, really hard. But to 2 degrees, it might still be possible if we take some actions into account, such as those that Louise just presented previously. Now, the building and construction industry is one of the main responsibles for this, and it accounts for approximately 37% of all global emissions. Now, these 37% include both the global emissions for the production of materials, which we usually name embodied carbon, and also the operation of buildings, which have to do with the energy requirements of them and all of the operations that are required to keep buildings functioning. Now, what is the Portuguese context? So heating and cooling represent most of the energy needed for a building to operate. So this is about operational carbon emissions. And 88% of energy in Portugal is obtained from the national grid, which means there's a very small percentage of actually personal produced energy for oneself. We also have quite a lot of energy poverty and housing shortages. And the continuous use of construction materials such as concrete perpetuates these high energy and carbon costs. Now, there's quite a lot of studies in both Lisbon and Porto because they are main metropolitan cities. But if you try to explore a little bit on other cities in Portugal, you won't find that many research, and data is still quite scarce. So specifically in the case of Coimbra, in 2021, 826 families faced severe housing deficits, also which prompted governments to actually have more initiatives in that sense, but it was also a consequence of not building previously. And a lot of the times the choices that are made in this is actually to build very quickly and with very non-expensive materials, but which are also not very energy efficient or have any preoccupation with carbon emissions. So for our research scope and objective, our main goal is to assist in decision-making in architecture and construction, specifically by assessing the embodied and operational global warming potential, the free-floating interior temperature of buildings, and the energy loads of different envelope options. In this case, we're using a single-family building, a single-family house in Coimbra, Portugal.
So we assessed the global warming potential of this building at an early design stage. The BIM model was created solely for produce technical drawings. So it was not prepared for quantitative takeoff. The level of development, or LOD, was 200. BIM object had no material information. As Leonor was saying, we only considered the building envelope and a reference study period of 60 years. We only consider the global warming potential impact category, and the 1-3 product stage, the B4 replacement stage, and the big 6 operational stage of the building life cycle stages.
So regarding our methodology, what we did is we had the BIM model of our single family house that you can see there, which was classified with the Uniclass classification system. Then we used a specific plugin called Rhino inside Revit so that we could export the building into Rhinoceros and then into Grasshopper. And we have used the plugins Ladybug and Honeybee to address the building primary energy demands and energy loads. So after this, we assessed the global warming potential through a calculation or specific calculator. And you actually have an add-on which was developed by Sara here that you can check afterwards. We have a QR code that you can scan. And then finally, we analyze the best results and define what are the best performance solutions. Regarding our construction assemblies, we experimented with 3 different ones. Two of them very used in Portugal, one of them not so much. So for the first option, what we did is that we considered brick walls, general brick walls, and a concrete flat roof and a concrete floor. So the concrete floor is general to all three options because in Portugal, even if you want to build a house with a different construction assembly, let's say wood, for instance, you are usually obligated to have a concrete floor by the bank if you ask for money to build. So we wanted to make sure that it was still an accurate representation of what happens in Portugal specifically. So on option 2, we considered aggregate concrete blocks, which are also very used. And then on option 3, we considered a wood frame wall and a wood frame flat roof. And again, the concrete floor is the same. For all three options, we use the same type of windows, which are double glazed glass windows, which have a very good performance. And so in order that we could make sure that the comparisons were adequate, we considered for all of the assemblies the same amount of insulation because we know that wood and concrete would have different thermal conductivities, which could then have consequence in the analysis at the end. So for the energy simulations in Grasshopper, we have to define a couple of specific inputs. One of them is the number of occupants. So this was a 3-bedroom house, so we considered 6 people. We had to define a specific mechanical ventilation rate, which is the minimum that we consider usually for housing purposes. A rate of outside air infiltration, we considered the one for a normal building. So if you have, for example, a passive house building, this value is lesser. And if you have like a historical building, which we could consider a leaky building, it's quite more. So we use general values, which are also provided by Grasshopper. We considered also lightning density per area, and this is the value for LED lamps. If you use incandescent lamps, it's a whole different thing. An equipment load per area, we considered the normal housing values again, because if you have an office, it will be one thing. If you have a housing, it's a different thing. A simulation period of 12 months, so the whole year, and an occupancy schedule of 16 hours. This means that the 6 people that we are considering would be inhabiting the house at least for 16 hours a day. And with all this information, we conducted 3 different types of simulations. The first one, we do not consider any type of heating or cooling. We want to understand if the building is passively on its own comfortable for people. That's why we address the free floating interior temperature. And then the second one has to do with energy load. So I want to make sure that our building is always between 18 degrees and 26 degrees Celsius so that it is comfortable for people all year long. And here I can assess the amount of cooling energy and heating energy that I require. So this here is an overview. I know you can see everything, all of the nodes very clearly. This is an overview of our simulation script. So here at the left, what you have are all of the construction assembly. So each node defines a specific layer of material. Then in the middle, you have our geometry with all of the inputs that I just explained to you previously. And then here you have the Energy Plus simulator because Honeybee and Ladybug use the Energy Plus engine to conduct the simulations. And then afterwards, we would get our results, our exported results. For the energy simulation results, as it was somewhat expected because of questions of thermal conductivity. So the third option was the wood frame wall was the best options in terms of the less total thermal load that we achieved. However, it is interesting to see, probably because of the amount of insulation that we use, that all 3 options are comfortable for human use throughout the whole year. So if we would consider these options, so passively the building would be comfortable. But if I wanted to make sure, because this shows the average, not the minimum and maximum, if I wanted to make sure that the interior temperature would remain between the 18 and the 26, I would require this amount of cooling and heating energy. And so option 3 would be our best option, almost by less 2,000 kilowatts per hour for option 2 and around 1,300 kilowatts per hour for option 1.
To assess the global warming potential, we used a methodology developed during my PhD. This methodology defines 3 methods for quantity takeoff and for linking LCA data to BIM objects, depending on the level of development and on the design stage. This will allow a continuous monitoring of environmental impacts throughout the design. This tool is available now as a Revit add-on. If you want to install it, you can just in the first QR code. And we have also a publication if you want to know more about these three quantity takeoffs methods. In this work, as the model was at an early design stage, we used a method that was adapted for buildings with low level of development. This solution consists of creating a catalog of construction options that are stored in an external database. The uniclass code links the absolute quantities in the BIM model and the relative quantities that are in the external database. This approach resembles the grasshopper thermal model that Leonor was talking about. What we normally call the shoebox model, which consists of 2D surfaces. This approach means that we don't need to remodel the BIM model to simulate different material options. In this table, we have the results of the simulation. We can see that option 3 performs better than option 1 and 2. A1 and B4 are the embodied carbon, and B6 the operational carbon. Here in this graphics, we can see the embodied carbon by construction element. And of course, we can see that, as expected, that the floor and the roof are the major contributors. And here we can see the global warming potential over time. We can see the carbon spike during construction, and year 30 we can see another spike, which is the renovation. We also considered the 2% annual improvement in the energy grids, as you can see the edge areas. To conclude this work, we would like to highlight the importance of energy simulations and BIM-based life cycle assessment to balance operational and embodied carbon during early design. Of course, this study has some limitations because it's in early design. We have estimated material quantities, not the real ones. And we are using LCA data that is generic, and maybe it's not representative of the Portuguese context. And only a few life cycle stages were considered. Our future work will consider locally representative LCA data, which is difficult to find because in Portugal we have only 64 EPDs available in the DAP website. And integrate energy simulations and other circular economy indicators into the BIM-based tool that is under development in my PhD. Thank you. I would like to ask you if you could help me in my PhD and participate in this survey.
Yes, we would very much appreciate it. Thank you. Perfect. Because we were thinking of like starting offering coffees or something to have people like getting back to us. Yes, and then yes, okay, and answering the survey as well. Usually, food works. You know, if we try to. Thank you so much.
Okay, very well. So I would like to invite the authors to come here participate. By answering some questions from the audience. Okay. I forgot about the microphone. So if you please. So very well. So I'd like to ask if the audience has any questions you want to present.
Thank you very much, all everybody, for very nice presentations. But I specifically would like a few questions to Louis. One is why? I mean, why do you use the term upcycling when in reality you're just using window elements as window elements and wall elements as wall elements? It's more of a form of recycling than I mean, they don't become waste, let's say. But the other question is, do you take into account the energy used to cut the pieces? I mean, to put a disassembly into your calculations?
Uh, Very good questions. Upcycle, because the term it's recycle involves a process, typically a material process. An upcycle is kind of like recycling, but just using the element almost as it is. So this is the way that typically it is defined. Uh, LCA has a lot of uncertainties. I started delving with LCA, although that's not, I'm delving right now with LCA, but while I was taking my PhD, and I was lucky enough to have one of the main leaders of the field, and still has a lot of uncertainties, like as our colleagues presented, like only 64 EPDs in Portugal. That's very little, and in the EPDs processes, that's why it's very difficult to put all of the faces of LCA. In terms of cutting the material, there's a couple of research by Laniga Group, because they were observing that there's ways to make it extremely efficient, and it's very negligible. Recycling stuff, then it depends the size of the cutting, if it's very large or if it is very small. One of the things that we observe in our research is it's way more easy, more efficient if we cut very small pieces. If we disassemble in very small pieces, it's the distribution or the reuses of those pieces or those elements. It's quite efficient, but you have more cuts. There's more labor involved. There's more energy involved. But typically, depending on the cuts that we are using, the way that we take apart stuff, typically it's not a very carbon intensive process. Now, recycling, it is a very carbon intensive process. Now, upcycling, as I defined it to you, it's not. Is that, did I answer the questions?
Thank you very much. Does anyone else wants to ask any question? Well, apparently not. So you're firstly, yeah, absolutely no doubt. Very well. So I'd like to thank everybody. Thank you very much for your presentations. And we're going to make a break now for taking coffee.
Well, good morning. Let's start the following session. This is again a keynote speaker session. We have the pleasure to have with us Professor Mette Berghauser. It's really great to have you here with us. Thank you a lot for your time with us and your presentation. Mette is Professor of Urban Morphology and Urban Design at Chalmers University of Technology in Gothenburg, which I have the pleasure to know, and I really recommend you to visit it, and also the city, of course. She leads the research area on Spatial Morphology Group, which is engaged in research in the areas of urban morphology, space syntax, and design theory. Through primarily analytical and quantitative methods, properties of built form and describe and its significance for peoples and other species, use and experience of the city is investigated. Mette has published the book Space Matrix, Space Density and Urban Form in 2023, where the concept of density is critically examined. The book specifies the relationship between density and urban form, as well as the environmental, economic, and social effects of density. In addition to research, Mette teaches urban design. She's also the head of program of architecture with responsibility for the educational development of architectural education at bachelor's and master's level. So it is really nice to have you here. I'm sure your presentation will be quite insightful and interesting for the work of this symposium, and I hope you enjoy. Mette, thank you. The room is yours.
Thank you, and thank you for the invitation. Very nice. I actually have to make a small correction here because I'm not head of program of architecture anymore. I left that position the 1st of October, so very recently, which is actually good for my health because this was a bit too much. But it's a great pleasure to be here. I've actually enjoyed a lot to see all the presentations that are more on the building level, where I do not work so much with, but I'm very interested in. I'm originally educated as an architect, and then did my PhD in urban design and planning in Delft, University of Technology. And since 2010, I'm in Sweden. I was at KTH a bit, and then I went to Chalmers, which indeed is a great place to be, actually. And it's a huge pleasure to have to be able to lead the spatial morphology group. I have a picture of all the members because what I will present is actually not only my work, it's also the work of a lot of other people in the group. So it's important to say that. Okay, let's get started. What I want to do today is to actually talk about the importance of how we represent the built environment, which is at the core of what we have been discussing a lot, but also to link that directly to kind of a plea for putting evidence-based design more on the foreground to be able to address all the challenges that we are facing. And we heard a few of those already today. And I thought I will start with a few of these quotes, because in architecture, and we have seen a bit of that also the last days, there's one artistic approach, let's say, this more within architecture, which is extremely important. And we saw these generative sort of forms occurring that in iterative processes that you can do with computational means, but you can also, let's say, what we did traditionally. We just sort of put it on the back of an, let's say, we go to the cafe and we draw something and we don't really know what's happening, but we create beautiful things. But it's not only about beautiful things, they also have to perform in certain ways. And I think that's the fantastic thing about architecture and urban planning, that you have to do both. We have to be both technical and artistic at the same time. And all these quotes kind of are talking about this. And I think an evidence-based approach is a way to actually handle that we assess what we are creating all the time to actually make sure that the world becomes a bit of a better place to live in. And I will not talk about these huge challenges. I mean, you know, but I still have one, let's say I have this slide to just start off with. And I work, kind of everything I do has to do with these two. There is an urbanization trend. So cities are part of the problem, but also part of the, should be part of the solution, because people are moving into cities, they densify or not. And that has impacts on how we live our lives, how we move around. Do we use public transport or not? Are there possibilities for that? But it also affects ecosystem services, biodiversity as such. So urbanization is something that we just have to handle. It's on the table that we have to deal with. Then we have the planetary boundaries, and there are many of them. Climate change we have talked about a lot today. It has both, we have to sort of mitigate it, so reduce by the way we design our cities, but also have to adapt to the impacts it already has, like the hazards that we discussed this morning. But also biodiversity loss is actually part of our responsibility, because if we urbanize, the way we do actually impacts the way nature can thrive and let's say the healthiness of nature. And you probably all know this donut of Raworth talking about the ecological ceiling. So, I mean, we have one planet we have to handle, that's what we have to work with. But we also have a social foundation. So all our solutions have to sort of kind of cope with both of them. People have to thrive, should improve their health, and all other species' health, but it also has this ecological ceiling. So everything I do, I try sort of to sort of bring this, put that in that perspective. And when I started working on my PhD for many years back, and the book that you mentioned, the 2023, is actually kind of a continuation of the book that already published in 2010, but we just added things on and made revised versions, etc. So the latest version is an open access book with the latest findings in how we represent the built environment in the model. We talk a little bit about evidence tools. I will not come back to so much. So back to density and how, as I said, 65% of the papers that I read about the impact of densification, they use a very, very crude way of measuring density. And even if we would use floor area ratio or floor space index, these three examples have the same. So even that is for an architect not very sort of satisfying, because we can agree that these are very different urban forms, very different types of buildings, and most probably very different performances in all kinds of things. Daylight, how much space do you have to do other things in the out, let's say your open space related to your house. Also, the street network is very different. So everything is different, kind of, but they have the same floor area ratio. So what I did in my PhD is to develop a way sort of to grasp this better. We thought this cannot be the answer. We leaned a lot on the work of Martin and March from the 1970s. We already started to sort of look into the logic of different types of buildings and variations in both floor space index, but also coverage, ground coverage, etc. So what we did is actually look into, okay, what ways of measuring density are out there? And open space ratio is one of them, ground space index, floor space index, all were used. The only thing in a way what we did is to put them together in a mathematical diagram, sort of let them talk to each other because they're mathematically related. So you can actually put them in the same diagram. And then what we did is to look at a lot of examples, empirical examples. And here you see two examples that say actually the same thing as my first image. It's two very, very different urban environments that have the same floor space index. So they are in the same horizontal line in the diagram. They have like a floor space index of 2. Floor space index is the same as floor area ratio. I think you know what it is. It's like how much floor area do you have in relation to a plot of land. But you see also that the ground space index of these two is very, very different. So this one takes 13% of the land is built upon, while this one is almost 50%. And that means that they are positioned in different locations in the diagram. Also, the height is different. And that's the only reason, let's say, that they can have the same floor space index and so different ground floor coverages is because they have different heights. So these, as soon as I reduce the height of that one, it would sort of walk down along the diagram and become another typology. So this is a very elegant way to sort of capture typologies. And we did this cluster analysis and found actually clusters in this diagram, capturing through density metrics, also building types and building qualities. More informative for an architect. And here you see a few of those examples. When I did this, actually, it was a lot of just hand work. The data was very bad. So what we actually did was we got the plans, we measured it in AutoCAD to start with and calculated the floors ourselves because we tested to get the data from authorities, but it was so bad that we stopped. So we did everything actually manually. And I will show you how we now have taken a lot of steps to automate the whole process. But going back to this image, of course, we would like to see this space matrix model instead used to look into all the impacts of densification. And there are very, very few studies doing that. Another thing to sort of think about when we talk about density is it's not only about that having more variables captures the urban environment better, but we should also be very aware of the scale of the analysis. What land do we actually look at? And as I already showed you earlier, let's say if you use the population data, it's on the census tract. It's kind of a morphologically weird unit. It's let's say it's developed for completely different reasons. So what we did here is to sort of, okay, what are the morphological units we want to know the density of? Well, the plot, the block, the urban fabric, the districts. You probably recognize the way of that's the way a morphologist would talk about, let's say, relevant units. But the differences, you see the results, the floor space index, it changes, of course, because the higher scale we go, the more unbuilt land is added, so the density decreases. If we would go to the city, it would drop even further. This is logic. I mean, it's but the way we do this, so the choices you make here are very, very important, which you all probably know is known as the modifiable area unit problem. So this is an important thing. And actually we thought, so I did this, this was my PhD, but this was the way we did it. But it was a bit unsatisfying. So what we did later was to actually move away from this area-based definitions where you sort of say, this is the unit, and then I calculate my density, to go to an accessible approach, accessible density approach, where you actually have a floating border. So every building or every address has its own neighborhood. Walking 5 minutes or 10 minutes or 15 minutes, and then you calculate all the buildings that you reach, and that becomes the accessible density of that building. That's neighborhood's building, so to speak. And every building has its own. So in that sense, it's floating borders. But it becomes very, it's not only interesting in terms of that it allows you to analyze whole cities, regions in a very easy way, but it also solves kind of the MAU problem because you can actually do this on different radii and see what's going on. It becomes easier to study that. It makes this not irrelevant because for practitioners, this is very relevant. Because if we prescribe density in zoning plans, we do it like that. We don't do it like that because it becomes hard to control, etc. But these are linked. It's the same data, and they are telling us different things. So it's important to always look at both. And I can exemplify. So here we have a high density plot, which is actually located in a low density neighborhood. While this plot is low dense, located in a high density neighborhood. And in terms of what we can expect in activities, let's say economic activities, flows of people moving around, most probably that one has higher economic activities than that one, although the plot density is higher here. So this is it's an important thing to sort of understand, let's say, how to describe the built environment and what it tells us, what it doesn't tell us. We use this approach to actually start mapping whole cities. And what you see there is Amsterdam, and it's a density map of Amsterdam, but it's not floor area ratio. It's actually floor area ratio, coverage, building height, and open space ratio at the same time, representing building types in Amsterdam, which is a very informative map. And we did that for many cities. And this approach has been kind of, you know, these sort of developing typologies with this logic has been spreading. In my group, we did the plot types as well. We also worked with street types with Michael Serra, and Alice Vialar developed block types, a little bit parallel to what we have been doing. But this is kind of similar approaches. So you look at the morphological element that we know is important, and enrich the description of that so that the data represents also something that is really important from an architectural perspective. We did a similar thing for streets, and we have seen quite some space syntax studies in this symposium, and you, I think, all are familiar with that. But what we did here is actually, instead of looking at 20 maps that show angular betweenness on the 500 meters, 2 kilometers, 5 kilometers, 10 kilometers, 15 kilometers, and then you have to sort of try to understand. They are all relevant and informative. But can we economize this into a typology that actually describes for each street its profile across the scales? You have some streets that have low centrality all the time, independent if it's a local analysis or a global analysis. We call that a background street. Then you have other streets, it's the C1. So you see this is the scale of analysis, but it's low all over throughout all the scales. Then you have another street, what we call the city street, which actually have a relative high value and increases when you go to higher scales. So it's the street that is important for the movement patterns in all scales. So you will meet a local person going to the bakery and someone crossing the whole city. Both people are in the same street segment, most probably. And that's what this city street is capturing. And then you can start mapping cities with that. And we don't need, let's say, 20 maps, but one map is enough to describe that. And you see kind of a superstructure emerging of the city street, kind of a super grid of the mega block, or how we want to call it. And I thought I will give you a little bit of detail, because we have now also, after that we developed this, we have now made a script that sort of captures the whole process. So going from extracting the street network from OSM, transform the graph, filtering, cleaning, then we go to the PST tool that I talked about earlier, to segment, do the analysis on all scales, and then you do a few statistical analysis, and then the output, as I just showed. And this is, let's say, kind of almost, who talked about the click on the, let's say, it's just one button and then the whole thing runs. Not completely, but almost. So what I show you a few of those. So in the PST tool, what it first does is it runs the analysis on many, many scales. So from the very local scale to the global scale. And so this is this enormous amount of maps that you have to put on the wall, and then you have to sort of synthesize and try to understand what's going on. After that, we do a PCA analysis, so principal component analysis, to instead of having these 20 maps, we have actually 3 that explain the variation in those 20 maps. So that's already a kind of a reduction and grasping easier what's going on. But from that, we even do a cluster analysis, and then we arrive at the one that I showed you earlier. And here you see a set of other cities that we recently did, and a zoom in. And the interesting thing is that it captures the main structure. It shows the background streets you don't even see here. They are so light. I think they disappear almost. But it's a very, very powerful way to sort of see immediately the structure. So this is a lot of work we do, sort of developing these descriptions of the built environment, enriching them without making them, I mean, they're complex, but they're complex in the sense of the information they embed, but actually when you look at them, they're quite easy to grasp. Besides this, we want to develop this evidence. Yeah, okay, then we have all these nice maps, but what do they tell us? And of course, you know this, the theory of natural movement, where centrality, so the analysis that I just showed you, the street types, is an important one, informing about the potential for pedestrian movement and co-present in those street segments. But in the theory of natural movement that Hilja developed, it's also the attraction are there and density. So what we did a few years back is to actually thought, let's do a large scale survey to see whether this indeed holds in different cities, different neighborhoods, from very low dense to very high dense. Let's see what happens. So we went to London, Amsterdam, and Stockholm, and put out sensors in those cities, in 53 neighborhoods, in 3 cities, in total almost 700 streets. Boxes like these were put on the, let's say, street corners, and we could actually follow people moving through our neighborhoods. And so it was kind of, you see here, you see all the neighborhoods spread out over the cities. And on the yellow points, we had these boxes that counted, okay, how many people passed, and we could also follow the same person walking through the neighborhood, so which route it took. And what it showed is that, so when we did all the correlations, 65% could be explained by only 2 variables, and that is the street type and the density type. And then we have done a lot of alternatives and also looking at the separate variables, but that is kind of it's kind of 2 variables in a way that are rich in themselves, explain 65% of the pedestrian flows in all these neighborhoods. And it was the build density that explained the number of people, and centrality, the distribution of them. So in each neighborhood, whether it was a villa area or a very dense inner city area, we found kind of a high street, the main street with the most people. Of course, there were less in the low dense areas than in the high dense areas, but we saw these variations. And you see that sort of represented in those graphs, representing the density types and the street types. And the higher the bar, the more people we counted in the streets. We took recently a next step, because this is all describing how the built environment influences the probability of people being there at the same time. So saying something about the intensity of flows, etc. But what we thought is, can we also predict in a new city where we don't have observations? So we used a model that was trained in Stockholm and predicted the flows in Gothenburg. And when we had a set of validation data to see how well we did. Was not so, I mean, this is another, it went quite well. But the exact numbers are hard to detect, and especially those that have very, very high numbers. And we actually know that from earlier studies that it's hard to predict those. But if you look, so it was kind of a correlation of 0.52 that we got for this prediction. But what the interesting thing is, so this is the observed counts, and these were the predicted counts. And what you see is that the streets, the segments with the highest flows are also the highest flows in the predictive model, but the exact numbers are not correct. So that's the reason the correlation is not that high, but actually the distribution, where do we find most people and fewest people, that's very good. From an urban planning perspective, that's actually probably good enough. But here a lot of work still is needed to go further. And we also went to combining different ways of modeling. So what we do is actually statistical models to find out the numbers of people in different street segments. But then we link that to an agent-based model, actually as an input data, to know how many agents do we let loose in in the outsides of the agent-based model. So how many people should start walking here and there? That came from the statistical model as an input. And then they did the agent-based, you give them some rules of how they behave. And that was on the right, you see the observations, so the real movement patterns on a location in Gothenburg. And this is work on the right. The agent-based model is not the work from my team. So we actually collaborated with another team in Gothenburg to do this. But this is the way, let's say, to get our ways of modeling the built environment also validated with observations. And what does it tell us actually in the end? And most recently, we have been moving to, we're doing this and stuff, density, centrality, movement patterns, economic activities. We have been doing that for many years. We could keep on doing that. But we decided to also broaden, let's say, our understanding, and especially looking into the conflicting impacts of urbanization and densification. And then I go back to this image that I showed you earlier. Because we have very little understanding actually about the ecological impacts, some health impacts that very often, if you read all these papers with the negative impacts of densification on these aspects, some are very explicit about it. Sometimes it's a bit more implicit, but it's very often about the availability, accessibility of green areas, because they reduce when you densify. And that has an impact on ecology, of course, a negative impact, but also on health. So what we decided is let's add the layer of the green and blue infrastructure. So that's what our recent work and current work is very much about that. So to summarize, so this is kind of our research agenda, so to speak, for the coming years. So this we have done a lot. Urban form, the built environment in relation to social processes and economic processes. We have done a lot of work here and many others, and we know a lot. There has been a lot of studies. We have a few people in our team also to look into the ecological processes like flooding, urban heat islands, and how urban form affects that. But there's not so much work about the interaction between those two. So that's where we want to head for. And it has to do with that why are green areas healthy for people, or let's say why it has to do so then you have to go into that interaction. So what we want to look into is how by the organization of the built environment we influence the frequency of interaction. So how often do you actually do you interact with nature? And then nature can be for recreational purposes, but it can also be biodiversity, et cetera, But also to look actively into because there are negative and positive interactions. Of course, we want to reduce the negative ones and improve and sort of optimize or increase the positive ones. And also we want to avoid severe negative interactions. So it's not about, oh, let's get the green inside of cities and everything is fine. You have to sort of design that very consciously. So what we do there is so this is, I already showed to you. You have kind of a theoretical model how these interactions take place. What are the important variables? On the top, you have the urban form variables that we have been developing. And here is the phenomena we want to understand. To understand the green, there is a similar kind of model. It has to do with habitat quality and urban ecology and landscape ecology. They have developed a lot of, let's say, knowledge. So we don't have to do that. It's out there. And habitat connectivity play an important role for species mortality, mobility, and diversity. So it's not so that we are going there. We want to be in this arrow in between. And so you can build up this conceptual model further. So to make this a bit more sort of understand what we are talking about. For instance, habitat connectivity in cities is very much affected by accessibility, the street network. Those create barriers for the habitat connectivity. Also density does. So there are these links between those two that we want to understand and use. And I give you just a few examples. This is really, let's say, we are in the middle of doing all this, both theoretically and developing the models and doing the observations. But one example is a PhD thesis that was finished 2 years ago. And she looked into trees, urban trees. And here is a very, I mean, trees have a lot of ecosystem services that they provide. And of course, to provide those, they have to also to be in proximity to people. So where do you position your trees to be most effective actually to providing those services? So what she did, she looked into all the, I don't have to go into detail, but one example that where she tested this is to look into the visual exposure to tree canopy. So where are they? Where do we see them? But also you can add a lot of other services that they provide, shading. I mean, there can be many things that you could add here. Look into pedestrian densities based on the space syntax analysis. And you can overlay those to actually develop a tree planting priority plan. So where should we plant trees so that they have most impact on people passing by? So that is one way sort of to combine this, as a kind of a low-hanging fruit, because this is relatively easy. And another thing that we recently published with an ecologist in the group is to actually use this model about habitat quality and habitat connectivity that we know affects species mortality. But what he did is to actually use our models for attraction density and accessible centrality in his models and improved the predictive power to very high, to large extent. So that is, let's say, so here we just use our models and put it in his model that is quite common in understanding mortality, mobility, and diversity of species. And he uses a model like this, where then actually one of the frictions becomes density and centrality. And based on those frictions, and you have the quality of the green areas, those combined give you a dispersal map of these species. And etc. So this is a kind of, we just implement our models in a model that is used in ecology. What we are doing now is to look into our building types, centrality types, and the green areas and their connectivity, and look into does this combination, this built environment setup, let's say, of all these variables, does it impact biodiversity? And then we look at birds. And what we actually want to show with that, so the hypothesis is that you can create high dense areas with green, with a good connectivity that has a higher biodiversity than low dense areas, to get rid of this idea that high dense is bad for biodiversity. So what we did is to have, so all the dots here are parks, green areas of all kinds, very small. Sometimes it's only a row of trees. Sometimes it's a small pocket park. Sometimes it's a bit bigger. The biggest ones are the bosses here. We call that reference observations. And we spread the parks, let's say, across different types of density. And we only look at the higher density types. So you see them here. This is the inner city of Gothenburg. And we have, so we had 30 sensors last spring in those areas. And what they do is they look like this. They're very small. We just put them, we actually have bought a bit better boxes than just a plastic bag, but that doesn't matter. And it counted for 3 months. It sort of collected acoustics. And then we used machine learning to identify which species are there. We only looked at birds for the moment. And we are not interested in a specific species of birds. We just want to know the richness of how many different do we find here. And birds are very, let's say, a good thing. I mean, they are good indicators of biodiversity, but people are very attached to birds. When we hear birds, it does something with us. I think we have never had so much attention for a research project that we did. So they're calling us from the radio and asking it, because it's birds, I think, that we are looking into. When we counted people, they were not interested at all. But when we count birds, they are very, very interested. So this, I don't have the results yet. So we did a pilot. So what we get is that we know, so these birds, they were there. You see how many There are actually how many sounds we collected. It's not, it can be the same bird that we don't know. And so you get that, a profile, and we get this profile per site. And we also get a profile of richness per site and also over time. And now I didn't bring that picture, but what we already have seen is that actually the big parks in Gothenburg have not the highest richness. It's very often the parks that are much smaller, in a certain way positioned in the urban fabric, that have a very high richness. So it's absolutely, we already have seen, let's say very roughly looking at the data, that it's a much more complex picture than that. Indeed, higher density have lower diversity, or bigger parks have a higher diversity. It's not like that. It's much more intricate, and we hope to find, let's say, the variables that really trigger how we could combine high density with greenery, that sort of where biodiversity thrives. Besides that, people thrive. So that's where we are exactly now. Going back to this sort of overview of, we need to have the right models, representations, we need to collect evidence, and that means doing observations, really sort of get out there and know how do our models affect these types of phenomena. And then we need to develop the tools. And I just summarized, let's say, a few challenges. I mean, there is a research agenda for us, what we need to do, but there is actually also has implications for education, because to work in an evidence-based approach, you need to know as a designer what evidence is. You need to know a bit more how you should read those papers that present this evidence. So it requires new skills, maybe. It also requires skills to use spatial analysis to make the evidence site specific, because it's not just reading that this large park is good for that. I mean, it's always a lot of variables that come together. So you need to do analysis to see if your scenario, your proposal is performing well. For practice, there are also things to look into. I think standardization, for instance, of the types of analysis they should do is one of those steps. We cannot sort of let them find out themselves. We have to help out there. But for research, if we look there, I think, so this one, the metrics, the descriptions of the built environment is key. I mean, that is really, I mean, it's really on, I think, on the table of urban morphologists to sort of to develop those. And then take the step to what does that mean for data, and talk to authorities and say that you should start collecting this and this and this data for this and this purpose. We need to do larger sample size studies. We need to do longitudinal studies. We need to do post-occupancy studies to really sort of get better in this high level evidence. And I think we should also start working much more with systematic reviews, meta-analysis, to collect, let's say, not only one study that says something, but 20 studies that say the same thing, and then we can put it out in practice. I think this is really it's kind of a collective research agenda that I see as very important if we want to go, which I think we should, in a more evidence-based and research-informed design practice. Not meaning that the artistic approach is not important. It's both, like I said in the beginning. And here's my team working on this and a lot of papers that I've had in my presentation. Thank you.
Well, thank you, Meta, for this wonderful presentation. I have a few questions, but before, I would like to know if someone, yes, Anna, can you have a mic for Anna, please? Anna is at the bottom of the room.
Thank you. It's working. It's working. Thank you so much for your presentation. It's really inspiring to see the efforts the entire team can go through to reach so many people and to reach planning practice, which is one of my primary focuses in research right now. And because of that, I also wanted to ask, in my research, I've been finding that this seemingly apparent relationship between the tools that we make, the rationale behind those tools, the impact that those tools shows that urban form has on socioeconomic dynamics. When we're trying to transmit this to planning practice, sometimes this gets lost as one element that seems to not reach. And this contact sometimes not sometimes, most times isn't easy. And I was wondering if in your experience you have maybe some pointers, not the exact word, but some pointers into how we can standardize, as you were saying in this final slide, this approach from quantitative to rational to socioeconomic impacts to approach practice more easily.
Yeah, very good question. And this is very hard. I know we have been, let's say, struggling. I think we are sort of getting at the point. So we have been working with in Sweden since I moved to Sweden a lot with this. And that's now 14 years. And actually only now we are at the point that we together with them, so a few of the forerunner municipalities are developing standards. It's doing it together with them. I think that's the key. But it took us this long to actually get that point that we sort of go together and spend time and money to do this. And I've done something similar actually already in the Netherlands. So when I did the density, so my PhD actually became a standard for calculus for measuring a density. So there is a standard, which is actually a European standard because no one else had it. So if the Dutch sort of publish it, then it becomes immediately a European standard. It hasn't been flying, let's say that everybody is using it, but in the Netherlands, they use it. So they have the whole country kind of a space matrix approach, using all the variables and all the different scale levels. They have that, and the data is gathered in that manner, etc. So there are, let's say, examples where you, in both cases, it's kind of the step towards standardization that actually helps a lot. And in the Netherlands, it took me 3 years to get that standard in place. Also with stakeholders and the whole process of doing that.
Yes, Vinicius, and then Rudy.
Hello, I'm Vini Neto, Cita FEUP, and I'd just like, obviously, first to congratulate you on this wonderful pieces of research you showed us. And I was particularly interested in your, actually the last part of your presentation on this idea of going further in terms of integrating kind of thinking about relations between cities, social processes, and nature, other species. We can, I'm not sure, I mean, if this is completely obvious, the fact that even our concepts of sustainability are so anthropologically centered. It's so impressive to see that it's all about the future, our future generations, of which indeed it is, right? But we have to take into account the survival of other species which are disappearing by hundreds a year or so. So I really salute you for this research line you have there. And the idea of this, stimulating these interfaces and researching these interfaces between urban life, if you will, and the life of other species surrounding us and within and around cities. So the idea of exploring this interaction, the contact, we talk a lot about social diversity and the importance of intergroup contact in order to stimulate awareness of social differences and other groups and naturalize those differences. This has a positive impact for, obviously, most of our lives, if you will, but so little is spoken about the contact from in between species, right? So just a comment, and if you want to elaborate further on that, or you know, I would love to hear it.
No, I mean, I think it's kind of I see it as key for future urban designers and planners to actually be able to handle this, and it's kind of natural, can come to our the way we have been thinking. We create places of high interaction between people. I mean, it's not that far reach to think about, okay, can we create places where you have high interaction between nature and people? We should also create places where actually in cities, we create segregation between the two, because sometimes they have to be segregated, so separated from one another, and we can design that. I mean, we are very good at that. That's the whole design skills that we have, but we just add another perspective. I don't think it's very, and I noticed this, for the students, it's very easy to grasp this. They run with it immediately. If you provide them with the knowledge, the tools to do it, it's very easy to integrate it in the design proposals. And you get, what is so fascinating, you get new typologies, new ways of looking at cities. So I think it's a very fascinating approach, both, let's say, in teaching and in research. It's very rewarding to work with this.
Rudis?
Yes, thank you for very interesting lecture, and a lot of information to process and to think about. So maybe my question will, is very specific. I'm just trying to, relate it to some of the work I've been doing. But I was wondering if you might be able to, if you have a opinion, or you might be able to give some feedback on the use of local climate zone classification, which is of course easily done based on satellite imagery, because there seems to be quite a similarity between with the building types. So yeah, that was my question.
No, yes, true. There's a lot of similarities actually, especially if you integrate it with the, let's say, I integrated the unbuilt space in, let's say, in the typologies, but actually not sort of putting information about what kind of open space is it green or not, and that you need for the climate zones. But if now we are adding the green layer and the blue layer, I mean, immediately you actually get there. So I think that I haven't thought about it, but because in a way the climate zone types, they work, let's say, and we published one paper with one of my postdoc researchers that looked actually into how effective they are, and he developed an automated method to actually do this indeed with imagery. So there's not really a need to develop another method for that. So what we very often, but what I think we could add is the multiscalarity, because they are very, I mean, you look at them as very area based, but we of course also know that it's very dependent on, are you part of a bigger system of greenery? So I think there we could really add something. And that is the same kind of knowledge that you need to talk about ecosystems that are thriving and healthy. You cannot look at individual islands or habitats. You have to look into the multiscalarity of it. I think very often that's where we go. It's both in the density and the centrality and the greenery. It's like looking at the local and immediately include how it is embedded in a bigger system. So I think there we could probably contribute. I haven't thought about it, but I think that's the way where we could contribute a lot.
Tasos?
Yep. Hello. So thank you for the overview. I knew a couple of things, but I saw some new research that I will go and read more about. For the first part, which I think we talked a bit yesterday, but now I've seen the work that you do is really cool, and the way you expanded it. So I'm referring, let's say, to the slide where it's also Miguel Serras and others, where your kind of classification that is, you're using all these different ways of calculating the ratios of buildings, the heights, the open space versus build space for every neighborhood, plus your speciality, of course, the accessibility. What do you think? Well, biased here. What do you think about an extra, let's say, so we've got plots, you did the work with segments, Miguel. What about, let's say, a full topographical 3D pixel-based, like I did it, okay, biased, plug there. What do you think about this being a standard way of representing the space across different scales, cities, and urban morphologies? Because of course you said it in the last slide as well that you're looking for this. And as well, that's why I started it, because I thought it might be a bit more easy for me. So that's my question. What do you think about this being like an extra bubble, let's say, in all your little projects there? And of course, the last part with the birds is super cool. And I've got a question, or maybe a suggestion. I don't know if it's a question because it's still early, as you said, about sound and the way it propagates through different parks with different trees and things like that. So the distribution of microphones might have something to do with the recognition of birds, let's say. So the smaller plots of land can pick up more activity because the decay and the canopy is a bit different. So the decay of sound and the filtering that happens, where in the big one, or maybe there's something else, which if it's something else, it's even more exciting. But the sound and the birds, I think it's
probably
it's amazing for a city.
Yeah, so maybe for the last one, I think it might be, I haven't thought about, we did some testing, let's say how far the reach is of what it captures and not captures, and mainly to sort of position the sensors that they not pick up the same sound, because then you sort of, but we didn't look into whether it has, so probably what we should do, like we also do with automated, let's say the sensors to count people, we always validated this by manual counts to sort of see if what does the machine count actually and what is the reality. So we might need to do the same for the sensors with the birds. But the other question that we have discussed a lot. So let's say, so what we have decided is that when we try to understand or describe the streets, we can add the multiscalarity. You could even add, which we didn't do, the width of the streets to describe, let's say, the unit or the element street, which is a morphological unit that, as a designer, we're designing streets. We're not designing, let's say, that in combination with the buildings, and because it would actually reduce also the innovations of new combinations, new assemblages, as you mentioned. So yes, of course, that would be interesting to, I mean, from a descriptive point of view, it could be interesting to combine all these and do a cluster analysis and see how these come together. We have done that mostly in relation to, okay, what do we find in reality now, which combinations occur more often? So that we have done, but we didn't combine them in the typology because we think from a design perspective, if you want to intervene, it becomes hard to know where do we intervene in. Because what part, and also when you start relating that package, describing the whole built environment in one thing to certain phenomena, it's not hard to know which part of the built environment is actually influencing. So that's part of the reason that we kept it apart. So we did the plots separately, the buildings separately, the streets separately. Now the green we will do in the same way, separately. but the question about, let's say, the climate zones is actually there, they combined. So there might be reason to actually also do that, but that has been the background, let's say, why we have avoided that in a way very actively. I'm not, yeah, so it's very much from the design and intervention perspective to keep it apart.
Oh, thank you for the inspiring presentation. I was thinking about, it's obviously that this methodology, these quantitative methods, this open a lot of possibilities. And have you ever included communities like a participative process, kind of in a cybernetic way, trying to think a recursive process, informed design, but including the complexity of the people issues in the process? Have you ever think about that?
Not inhabitants, let's say, but we are very often out in let's say, with practitioners, all different stakeholders, but not, let's say, but professionals, all of them. And then you get, let's say, another kind of knowledge sort of is put on the table, of course. So in that sense, yes, and that is, it's very, I mean, these models tell you one part of reality and what is important, but there are other aspects that are not included, where this type of stakeholders come in and actually know, yeah, but I mean, this we can never change because of, and there are a lot of reasons why you cannot sort of change this street segment, which would, from our models, would maybe be the most logical thing to do. So that kind of things we have been doing and developing scenarios with them. I mean, then you get also all these other kinds of knowledge in. So then it becomes part, our models become part of one aspect of the decision-making process, in a sense. So in that sense, we have tested and tried to evaluate, okay, what is the role of these models in the decision-making process side by side with all other things. And another thing that not me, but let's say I've been involved in, is to actually have more the perception of different places. But that's more like an observation that you can relate to the models. So not so much co-creation or co-design with local communities in that sense. And of course, I mean, you could do that. It's just not really our specialty. So that's more, let's say, in.
Thank you so much for the amazing presentation. I'm putting the hats of the architect. You started your presentation saying that you were trained as an architect. And I saw in my students that there's a growing interest on biodiversity. But as architects, we do most of us are very focused on the indoor environment. So how can, in this biased again, because I'm touching right now, I'm doing some research on view access and view quality, which could also have a strong relationship with the type of tools and the type of approach, particularly the last part that you presented. But how do you see, in your former self as an architect, how can this shape also the design of architecture and building technology, parameters for architecture, when we start zooming in to the building scale?
Yeah, maybe I should start with that. When I say architect, then an architect is a design of the built environment from the building to the city scale. But I'm trained at Delft, and there they have actually a master in building design and in urban design and planning. I did actually the master in building design. So in that sense, I'm, let's say, very long in the start of my career, I was more a building designer, and actually had a firm doing that as well, but that doesn't matter. But well, let's say buildings are part of the built environment, let's say the larger built environment as well. So if you want to create cities that create both places where people can meet, places where you can interact with nature in different ways, then I think buildings play actually a crucial role, because large part of and streets play a crucial role. So how do we create multifunctional streets that have both a social function and a transport function and an ecological function? The same goes for buildings. How can buildings become, let's say, part of that ecosystem of creating both a habitat for people to live in those buildings or work there, but they can or have also roofs that can be used for other stuff. They can have, so they're all, I think we should sort of see those artifacts having multiple purposes. And then the buildings are part of the whole story, both in flooding, recommendation. Buildings can play a role, let's say, gathering the water in a certain way. They can play a role with green roofs and green facades to be part of habitat, creating habitat connectivity throughout cities. I mean, I think there are many of those aspects, and not because you see these very cool buildings that are then green everywhere and they are in the middle of a desert of non-green areas. They will not do anything. They will not sort of contribute. I mean, they look nice. Maybe for people they can be actually thriving and nice to look at, but they will not contribute to biodiversity. But if you locate them well, they can. So that's kind of the kind of knowledge that I want to bring in then for architects to work with. So where do you position those green buildings to perform, let's say, in terms of biodiversity also?
Franklin?
Okay. It's amazing how the depth of research and well, where we get in the instruments of science to create new and beautiful cities. And well, I'm sure that those methods could create a city where every one of us would like to live. Nevertheless, the social problems of the city, you don't address them. I see nothing about it. I don't really know the Swedish society. I don't know if those are the problems that Swedish society has, but well, here in Portugal and in France, in Spain and England, well, what we see is that people are not, a great share of people in the cities are not really interested in this, but in getting affordable housing.
Yes.
Yeah, so what the problem is not the disappearance of some species of bird or butterfly, but of the low classes from certain places. And it's even less agreeable than this, because it's not only that is not the embellishment of the cities their problem. It's not their problem, but not only that, because I think in many cases they are against the embellishment of the city. Gentrification has been, well, some solution for making the cities better, but the low classes see the gentrification as something very bad. Embellishing the city signifies that they are going to be expelled from that kind of better city. So I know for a relationship that, for example, in London, some neighborhoods are organizing where the gentrification is accomplished. They are organizing the destruction of the embellishments. So they are not only alien to embellishment, but they are against embellishment. So I think you can help all of these people.
No, so I didn't talk about issues of segregation and gentrification, but actually there has been a lot of studies. I've done a few in our group. So when you look into, so segregation, I mean, it's a very complex topic, but you can sort of roughly divide it in two. So you have one part of segregation is about how, and the solutions that are discussed is to mix different groups in neighborhoods and offer different types of buildings, different, let's say, the social housing and ownership and all these issues, let's say, sort of to sort of have a mixture of different groups of society play in the same area. I've not worked with that so much. the whole idea about behind space syntax is to understand co-presence and intensity of people. And co-presence is a way to actually also address segregation. So who is actually meeting in public space? And the way we organize our both, let's say, where we have the higher densities and lower densities, but also how these areas are connected to each other, influences a lot who you meet in public space. So we have done studies, to just give an example, of different squares in Gothenburg, because in Gothenburg we have a huge issue. In Sweden in general, there are, let's say, segregated areas where a lot of people with low incomes are living together, and then you have the gentrified areas, etc. What we showed was that depending on how a square in those neighborhoods is integrated with the rest of the city, affects who you will find on those squares. So what we did is we interviewed those people, where do you come from? So we know how many people there were, and we knew from which other areas they came to that square. And the areas that were spatially segregated were also socially very segregated, while there were also locations that had a very, low income group living in that neighborhood, but they were visited by a lot of people from other areas in the cities. And we know from, let's say, studies in sociology that actually that meeting of different groups in society is extremely important for creating new norms and all that kind of issues. So in that sense, there's quite a lot of those studies. Our group is not specialized in that. There are other groups doing that. So I group that in the things that we know quite a lot already. Let's say the arrow that I said about centrality, density, and social economical issues. This is one of them. We know quite a lot. Not that we have solved it. I agree with you. We haven't solved it, because very often the interventions that are done in those areas are very local. And we very often say you should actually invest in connecting neighborhoods with one another to create interaction in public space, instead of that we want to create interaction by forcing people to live in the same neighborhood, which is also a very difficult thing actually to, it takes a lot of effort and interventions to get there. So that was one of my answers. Now I forgot the other question you had. But there is a lot of work done, let's say, in that field. Oh yeah, that was the other thing. There was actually also a lot of studies that show that the health gap which we have in all societies has actually also a lot to do with the availability, accessibility to high quality greenery. Very often the areas that have low, let's say, where a lot of people with lesser income, with another educational background, those are also the locations with lesser green accessibility, lower quality of the green. And when we build new, then we can invest in new greenery. But very often those housing that we are adding are also of for high income groups. So we are actually creating the gap grows instead of that it narrows. So I think part of this study is also to sort of understand how we can combine and what kind of qualities are needed to create high, let's say, but how you can create higher quality greenery all over the city. So there are, let's say, things that even address the issues that you link to, even when we started biodiversity and greenery. It's not, as I said, it's not only to create higher biodiversity and save some species. It's actually that we know that to create or to have an impact on the health and well-being of people, a high biodiversity green area has a bigger impact than one with lower quality in terms of biodiversity. So there are a lot of studies that have been doing that. So there's a lot of reasons, I would say, to look into green areas in cities and actively make that part of the design task of urban planners and designers.
I want to add to this topic about what Franklin said about the social layer that usually is attached to this sort of approach to the city and the way how we understand cities, and most of all, the way how we can do actually something to transform the cities in whatever direction. Most of the things that it's related to this topic about the social approach and the social framework for the solutions, they are not only dependent from researchers or from the knowledge that we can bring to cities. For instance, about connectivity and accessibility and centrality, etc. I'm with my actual activity, I'm more and more a technician and a municipal planner than a researcher, period. So I'm leaving the research part. I'm trying to implement the municipality some of the things research can give me to do as a urban planner. So in Matosinhos, we have in the master plan these areas about our urban areas available to be urbanized, that are areas that are surrounded by urban tissues, but they are voids. And those areas, they have terrains, that those terrains have they are property of someone. To intervene in those areas, we must call all the owners of the terrains and sit them in the table and say, look, we need to solve this. You cannot do it alone. We have to work together. Each one of you, because it's a perequative plan, each one of you has benefits and responsibilities towards this part of the territory. Most of the time, I would say 99% of the times, the discussion starts with what can I do in my terrain? And it's a building. And we are there to say, no, the first layer of issues that we have to address between us is what we need to connect in order for you to have a building, what you want to do there in a connected layer, a connected territory, etc. So this way of looking to the territory, this very individual way to look at the territory as the part I have of that territory and what that part can give to me, and nothing else is that important. It's something that, in this case, need to change. And the most of the conversation that we have with owners is try to shift the way they look to the territory, understanding that the territory is not the sum of parts, but it's a whole. It's more than just to adding the different parts and realize that this is a territory. So to change this mindset is something that is not that going to happen from one day to the other. And another thing is to attach this to urban policies. Urban policies is also something that engage politicians that are other part of the equation that need to be in this conversation. We have the researchers, we have the technicians, we have the owners of the plots, of the terrains, of whatever, and we have the politicians. In the end of the day, who make the decisions about the territory are the politicians, because they won the election. They are all of us mandated through our votes for the politicians to decide whatever's over the territory. So this is a track that is not only attached to one sort of stakeholder to handle all of this, but in order to involve all the stakeholders, this process that we see today, they need to take into account these different levels of conversation, of dialogue.
Yes.
And the question is, for you, we already talk about this. I'm really interested in to lower the level of the discussion, of the complexity of the dialogue that we have with these other stakeholders. If I go to an owner, to someone who has a terrain in these areas, and I talk about these things in a very complex way, they will be looking at me and they won't understand anything. And at the end of the meeting, they will go, we end the meeting as they entered the meeting with the same idea of what they want to do. So one of the topic is how to put this in available meanings for those who do not are so comfortable with all of these ways of talking about this. And the other one is the politicians. And about the politicians, there's always also another problem. It's the political cycle. And to think about the territory is not about to think about the 4 or 5 years of a political cycle or 10 years of a political cycle, for instance. You talk about a lot in this last part of your presentation, all the green issues. Green issues to be aware and to transform the territory, they will take years. So it's an option for a politician to make. Look, I'm going to do something that I won't be taking part of it as a vote. You understand? I'm going to do something that the one who's going to get the results of this, I'm not the one, because I won't be here because my political cycle is already in. So this is also a challenge. So I think we have to, and I'm talking all about this because you, in a very concrete way, you establish this straight relation between theory and practice, and the effort you are doing to connect and to bridge theory, research, and practice, and the way research and theory can actually transform the cities. Because as Franklin said yesterday, or the day before, who's actually transforming the cities are the real stakeholders, the imobiliarios, I don't know, the real estate, the real estate stakeholders. They are the one transforming the city. So to grasp this, the question is, in this process, I understand that in the initial part of the process, you develop a lot of effort to assemble this very clear track, research track. I wonder if in the last part of this, where do you think you can start to establish very clear toolkit tracks, for instance? I try to implement in the division the space matrix methodology, because we have now opportunity to think about a huge part of the territory in Matosinhos that is going to be vacant because a refinery that is not going to be there anymore. So we try to understand the adequate density to occupy that huge part of the territory that is going to be promoted by the owner of the plot. But I wasn't able to say my team, look, this is Space Matrix. This is a book of meta. You read it, and then we
have to
talk.
read first a book like this.
And they look at the book and say, well, it's going to take time.
Yeah.
Okay, take your time.
Yeah.
A toolkit would be much easier for them to do that. So this is a challenge for you in terms of how to bridge this. This is something that I would like you to elaborate a little more, if you have that in perspective.
Yeah, it's a very difficult one. It's a bit, the first question was also related to this. I think a way to, I think what very often helps when I talk to practitioners and politicians and going through the goals. So the goals that they have set, if you can link those to the spatial analysis that actually help you to inform whether you reach your goals using, as let's say, in between KPIs or some metrics, let's say indicators, to sort of link it to those goals, could be a way, because if they often the goals they have agreed on, the aims of, let's say, that can be municipality, it can be national, it can be the global, let's say, our sustainable development goals. I mean, the whole range, let's say, and even let's say the more local stakeholders have their goals. So that could be a very fruitful way if we could link those. then I'm very critical about having these sort of density thresholds. So if you have that, like you and Habitat did, if you have that threshold, then you're fine. We know that it's much more complex than that, so that's tricky. So I would actually go to a set of spatial analysis that can help you understand whether you reach your goals. It's a bit more complex, but I think doable. Making it also a bit, let's say you have the opportunity to make it context specific through that. So I think that's where I would go. If I would make a standard, I would not have a list of metrics and thresholds. I would actually have a list of analysis that you should do to, and how they combine related to certain goals. So I think there is and actually in our group, so we are doing, and now I showed you a lot of the, let's say, adding the green layer to our way of modeling. Another very big package is actually testing all the things that we have with practitioners and trying to get at these kind of standards, or you gave it a nicer name. Let's say this packages of can be, yeah, I think, let's say, in handbook is also not the way to go. But I don't have really the answer there. But I think I would say that key is that you actually, that spatial analysis on the urban scale is important to be informative, but that the output of that should be directly linked to a set of goals. So that it, from politician, is really easy to sort of go back from, I had this goal, and then I triggle back to this analysis, which becomes a map with performances. So they can also locate, or here we are performing well, there we are not performing well. So I think that is the way to go. And those maps or those analysis cannot be like 100. We have to sort of define, okay, what is the hierarchy? Which 3 should we start with? Should we always do? And then you can go deeper and deeper and deeper. I think that's the. But this is not easy. This is very important, but it's not an easy step to take.
We have 2 more. Yes.
Super quick, it's just a follow-up. I'm just piggybacking on this conversation. Is sometimes, even with my students, and now it's when we have soft goals, it's very, like, for example, social sustainability. When we talk about social sustainability, when we have these types of soft goals which are qualitative goals, it's very hard to draw criteria to say, like, am I good enough? Is this sufficient? So what is your opinion about that?
No, but I think that's such a big, broad goal. So if it's, but if we would say, we have to first define the goals more precisely. Actually, that's what very often happens when I'm out in practice. They have their list of goals. We also take them as they are. And then we have our spatial analysis, and we can somehow link them. Very often what happens is that through the spatial analysis, they are like, but our goals are so vague, because we let them also link them. They are so vague, we cannot do anything. So they start to redefine and make them more precise to be able. And then they say, some of the analysis do not link to this more precise goal, but others are. So it's also a way actually to become more precise in what are you actually aiming for. So that's very often the first iteration, that actually the goals become more precise. And then you can, for instance, like we said, if it's social sustainability, it should be, okay, let's talk about then segregation in terms of living, mixing different groups of people in the same neighborhood. That can be one of the things that we are aiming for, or it can be creating public spaces for integration. I mean, then, so if you become more precise, it's much easier to link it to interventions, etc. So I think that's the, and that goes in both directions, because we probably also start to understand that we need to analyze maybe other things if we understand the goals, these precise goals better. But like I said, they are also informed by the types of analysis and being able to formulate the goals better.
Yes, hello. Thank you for your research and your presentation. I have a dream, which is just digital democracy. Yeah, some way we are connecting with Franklin and David Viana. So the point, my question is, or maybe not a question right now, but a gate to be open. Are we close to giving the people the tools and not the skills, the tools to organize by themselves the city they are using? This is my question. Thank you very much.
Yeah, oh, that's also a very interesting one. Yeah, maybe. I think, let's say, all these co-design and collaborative development of areas, I think it's very important. And I think, actually, I'm not sure if, let's say, give the tools and then let them develop them themselves, but actually I would say that these tools, and if they are, let's say, developed well and sort of concise and connected to goals, you can communicate in a much better way. You can communicate about, okay, do we agree on these goals? Maybe we don't agree, maybe we should talk about that, and then we see the implications on the map. You can have this process in a much more richer way with communities. Because now very often we use, I mean, we present and then maybe you can choose about three scenarios and you can have an opinion about it, but that's not the same thing. But I think these kind of approaches could become part of a conversation, let's say, between professionals and non-professionals. I'm not sure if we don't need professionals at all, because it's often very difficult to understand, or it's like the long term and the short term. It's the same thing with politicians. It's always hard to talk about the long term because they are short term. With a local community, it's hard to talk about the system perspective because they are interested in their local communities, of course. But you can inform them that actually making a connection over there, the bridge, which is outside of their area, can enrich their area, give them accessibility to a green area that they don't have access to now. I think you can communicate that, but and showing what, let's say, also on maps that this has an impact, and then they will maybe fight for a bridge somewhere else that is not even in their own neighborhood. I think they can actually. I mean, we all smart people, so so I think it could. But I'm not sure if it's, yeah, maybe you could even just let it go all the way to the communities, but that it can become part of a conversation, a richer conversation. Yes, I agree. I think this can help. They don't have to understand all the details and even, but yes, maps help, actually, informative maps.
If we read well the Charter of Athens until the end, we'll see that in the last 3 pages, what he said is to accomplish what is till this page, there is a tool that we can offer population. It's offer the urban ground. It's clearly for the socialization of the ground. That is the tool, referring to what Plácido said, that could solve the problem. Well, in the new Charter of Athens that is being made recently, the last 3 pages disappeared. So I think we have here a problem. But I don't know.
Thank you, Franklin. Someone else? Well, Meta, thank you. Your presentation was really nice. The conversation was even better because we are here 40 minutes after with lunch waiting for us. So that's a very good sign about the interest of the discussion. And this meeting is all about the interest of the discussion also, not only the presentation. So I really thank you for that and all the participants in this conversation. And now I invite you for the lunch, and we have the second presentation is you after lunch? No. Yeah, it's you after lunch, Franklin. Yes. So we have Franklin, then the other keynotes session after lunch. So enjoy lunch, and we'll be here at 2 o'clock, 2:30. What time is it in the schedule? 2 o'clock, well, but it's not going to be possible, so 2:30. Portuguese delay. So thank you, and have a nice lunch. Meta, thank you a lot.